Welcome to the Ultimate Docker course. In this course, I'm going to take you on a journey and teach you everything you need to know about Docker, from the basics to more advanced concepts. So by the end of this course, you'll be able to use it like a pro as part of your software development workflow. If you're looking for a comprehensive and highly practical course that takes you from zero to hero, this is the Docker course for you. We're going to start off with a really simple project so you understand the basics. Then we'll use Docker to run and deploy a full stack application with a front end, back end, and a database. So you learn all the necessary techniques and apply them to your own projects. I'm Mosh Hamedani, and I've taught millions of people how to advance their software engineering skills through my YouTube channel and online school, codewithmosh.com. Now let's jump in and get started. Let's quickly talk about what you need to know to take this course. To take this course, you don't need any prior knowledge of Docker because I'm going to teach you everything from scratch, but you should have at least 3 months of programming experience. Ideally, you should have built at least one application, so you should know concepts like front-end, back-end, API, and database. It doesn't matter what languages and frameworks or what database engines you're familiar with, but you should know what these concepts are all about. Also, you should be familiar with basic Git commands, like cloning a GitHub repository, committing code, pushing, and pulling. Just the basics, nothing more. With all that, let's move on to the next lesson. Now, we all have different ways of learning things, but let me tell you what I think is the best way to take this course. This course is highly practical, so you should be active while watching this course. In my opinion, it's best if you watch each lesson, take some notes. You can either take notes on a piece of paper or using your favorite note-taking tool. Just write some keywords that help you remember what we talked about. Then, after each lesson, go through your notes and repeat the same steps I've taken in that lesson. So if I talked about a bunch of commands, play with those commands, make sure you understand how they work. If you follow that, I promise you, by the end of this course, you're going to master Docker and use it like a pro. All right, our journey to master Docker begins here. In every section, we're going to discover something new about Docker. In this section, we're going to talk about what Docker is and why it's so popular. Then we're going to talk about virtual machines and containers. Next, we're going to talk about the architecture of Docker so you understand how it works. Then we're going to install Docker and get our hands dirty. I'm going to give you an overview of your development workflow with Docker, and then we're going to see that in action using a really simple example. So by the end of this section, you will have an idea of what Docker is all about. I'm so excited about this section. I hope you are too. So let's jump in and get started. So what is Docker and why is everyone using it these days? Well, Docker is a platform for building, running, and shipping applications in a consistent manner. So if your application works on your development machine, it can run and function the same way on other machines. If you have been developing software for a while, you've probably come across this situation where your application works on your development machine, but doesn't somewhere else. Can you think of 3 reasons why this happens? Well, this can happen if one or more files are not included as part of your deployment. So your application is not completely deployed. It's missing something. This can also happen if the target machine is running a different version of some software that your application needs. Let's say your application needs Node version 14, but the target machine is running Node version 9. This can also happen if the configuration settings like environment variables are different across these machines. And this is where Docker comes to the rescue. With Docker, we can easily package up our application with everything it needs and run it anywhere on any machine with Docker. So if your application needs a given version of Node and MongoDB, all of these will be included in your application's package. Now you can take this package and run it on any machine that runs Docker. So if it works on your development machine, it's definitely going to work on your test and production machines. Now there's more. If someone joins your team, they don't have to spend half a day or so setting up a new machine to run your application. They don't have to install and configure all these dependencies. They simply tell Docker to bring up your application, and Docker itself will automatically download and run these dependencies inside an isolated environment called a container. And this is the beauty of Docker. This isolated environment allows multiple applications use different versions of some software side by side. So one application may use Node version 14, another application may use Node version 9. Both these applications can run side by side on the same machine without messing with each other. So this is how Docker allows us to consistently run an application on different machines. Now there is one more benefit here. When we're done with this application and don't want to work on it anymore, we can remove the application and all its dependencies in one go. Without Docker, as we work on different projects, our development machine gets cluttered with so many libraries and tools that are used by different applications. And then after a while, we don't know if we can remove one or more of these tools because we're always afraid that we would mess up with some application. With Docker, we don't have to worry about this. Because each application runs with its dependencies inside an isolated environment, we can safely remove an application with all its dependencies to clean up our machine. Isn't that great? So, in a nutshell, Docker helps us consistently build, run, and ship our applications. And that's why a lot of employers are looking for people with Docker skills these days. So if you're pursuing a job as a software or DevOps engineer, I highly encourage you to learn Docker and learn it well. And that's exactly what this course is all about. I'm going to take you on a journey and teach you everything you need to know about Docker so you can use it like a pro. No copy-pasting commands here. So in the last lesson, I briefly talked about containers. A container is an isolated environment for running an application. Now, one of the questions that often comes up is, how are containers different from virtual machines or VMs? Do you know the differences? Well, a virtual machine, as the name implies, is an abstraction of a machine or physical hardware. So we can run several virtual machines on a real physical machine. For example, we can have a Mac, and on this Mac, we can run two virtual machines, one running Windows, the other running Linux. How do we do that? Using a tool called hypervisor. I know, it's one of those computer science names. In simple terms, a hypervisor is software we use to create and manage virtual machines. There are many hypervisors available out there like VirtualBox and VMware, which are cross-platform, so they can run on Windows, macOS, and Linux, and Hyper-V, which is only for Windows. So with a hypervisor, we can manage virtual machines. Now, what is the benefit of building virtual machines? Well, for us software developers, we can run an application in isolation inside a virtual machine. So on the same physical machine, we can have two different virtual machines, each running a completely different application, and each application has the exact dependencies it needs. So application 1 may use Node version 14 and MongoDB version 4, while application 2 may use Node version 9 and MongoDB version 3. All these are running on the same machine, but in different isolated environments. That's one of the benefits of virtual machines. But there are a number of problems with this model. Each virtual machine needs a full copy of an operating system that needs to be licensed, patched, and monitored. And that's why these virtual machines are slow to start, because the entire operating system has to be loaded, just like starting your computer. Another problem is that these virtual machines are resource intensive because each virtual machine takes a slice of the actual physical hardware resources, like CPU, memory, and disk space. So if you have 8 gigabytes of memory, that memory has to be divided between different virtual machines. Of course, we can decide how much memory to allocate to each virtual machine, but at the end of the day, we have a limit in terms of the number of VMs we can run on a machine. Usually a handful, otherwise we're going to run out of hardware resources. Now let's talk about containers. Containers give us the same kind of isolation, so we can run multiple applications in isolation, but they're more lightweight. They don't need a full operating system. In fact, all containers on a single machine share the operating system of the host. So that means we need to license, patch, and monitor a single operating system. Also, because the operating system has already started on the host, a container can start up pretty quickly, usually in a second, sometimes less. And also, these containers don't need a slice of the hardware resources on the host. So we don't need to give them a specific number of CPU cores or a slice of memory or disk space. So on a single host, we can run tens or even hundreds of containers side by side. So these are the differences between containers and virtual machines. Let's talk about the architecture of Docker so you understand how it works. Docker uses a client-server architecture, so it has a client component that talks to a server component using a RESTful API. The server, also called the Docker engine, sits in the background and takes care of building and running Docker containers. Now, technically, a container is just a process, like other processes running on your computer. But it's a special kind of process, which we're going to talk about soon. Now, as I told you, unlike virtual machines, containers don't contain a full-blown operating system. Instead, all containers on a host share the operating system of the host. Now, more accurately, all these containers share the kernel of the host. What's a kernel? A kernel is the core of an operating system. It's like the engine of a car. It's the part that manages all applications as well as hardware resources like memory and CPU. Every operating system has its own kernel or engine, and these kernels have different APIs. That's why we cannot run a Windows application on Linux, because under the hood, this application needs to talk to the kernel of the underlying operating system, okay? So that means on a Linux machine, we can only run Linux containers because these containers need Linux. On a Windows machine, however, we can run both Windows and Linux containers because Windows 10 is now shipped with a custom-built Linux kernel. This is in addition to the Windows kernel that's always been in Windows. It's not a replacement. So with this Linux kernel, now we can run Linux applications natively on Windows. So on Windows, we can run both Linux and Windows containers. Our Windows containers share the Windows kernel, and our Linux containers share the Linux kernel, okay? Now, what about macOS? Well, macOS has its own kernel, which is different from Linux and Windows kernels, and this kernel does not have native support for containerized applications. So Docker on Mac uses a lightweight Linux virtual machine to run Linux containers. All right, enough about the architecture. Next, we're going to install Docker, and that's where the fun begins. All right, now let's install the latest version of Docker. If you have an existing version of Docker on your machine, I highly encourage you to upgrade to the latest version because your version might be old and not compatible with the version I'm using in this course. So here I'm using Docker version 20.10.5, okay? So to get Docker, go to this page, docs.docker.com/getdocker, or you can just Google get Docker or install Docker. Now on this page, you can see instructions for downloading and installing Docker Desktop for Mac and Windows, as well as Docker Engine for Linux. So on Mac and Windows, we have Docker Desktop, which is the combination of Docker Engine plus a bunch of other tools. At the time of recording this, we don't have Docker Desktop for Linux. We only have the Docker Engine. But of course, that might change in the future. So a couple of notes for my Mac and Windows users. Let's go to this page. So over here, you can download the latest version from Docker Hub. But before doing this, I highly encourage you to go through system requirements and make sure your computer satisfies these requirements. Otherwise, you might encounter weird issues. So the installation is pretty straightforward. When you go to this page, you're going to download a DMG file. Just drag and drop this onto the applications folder and then start it. This is very important. A lot of people miss that step. So when you start Docker Engine, by double clicking on this application, you're going to see the Docker icon on the top status bar. If you don't see this, Docker Engine is not running and there's nothing you can do. So you have to wait for this to start. The same applies to my Windows users. So back to this page. Let's look at the instructions for Windows. So once again, you can download the latest version from Docker Hub. But once again, make sure to read system requirements. One of the things that is really important is enabling Hyper-V and containers Windows features. So I don't have a Windows machine to show you here, but just go to the page where you can turn on or turn off Windows features. There, make sure you have enabled Hyper-V and containers. It's pretty straightforward, but if you can't find it, just Google it. I'm pretty sure there are tons of articles out there. Also, at the end of the installation, you might get an error saying WS2 installation is incomplete. Basically, what this error is saying is that you need to upgrade the Linux kernel that is shipped with your Windows. So just click on this link. This is going to take you to this page on Microsoft.com where you can download the latest Linux kernel. So just click on this link to get an MSI file, run it, and then you have to restart your computer. Now, once your computer is restarted, you need to wait a little while until Docker Engine is started. Depending on your machine, this might take several seconds or up to a minute. So wait a little while, then open up a terminal window and run Docker version. So over here, you can see the version of the client and the server. If the server, which is Docker Engine, is not running, you're not going to see this information. And this applies to all operating systems, Windows, macOS, and Linux. So make sure Docker Engine is running before going forward. If you encounter any errors, you can post your question on our forum at forum.codewithmosh.com. Or if you want a faster response, just Google the error message. I'm pretty sure hundreds of people have encountered the same problem as you. Now let's talk about your development workflow when using Docker. So to start off, we take an application. It doesn't matter what kind of application it is or how it's built. We take that application and Dockerize it, which means we make a small change so that it can be run by Docker. How? We just add a Docker file to it. A Docker file is a plain text file that includes instructions that Docker uses to package up this application into an image. This image contains everything our application needs to run. Everything. Typically, a cut down operating system, a runtime environment like Node or Python. It also contains application files, third-party libraries, environment variables, and so on. So we create a Docker file and give it to Docker for packaging our application into an image. Once we have an image, we tell Docker to start a container using that image. So a container, as I told you, is just a process, but it's a special kind of process because it has its own file system, which is provided by the image. So our application gets loaded inside a container or a process, and this is how we run our application locally on our development machine. So instead of directly launching the application and running it inside a typical process, we tell Docker to run it inside a container, an isolated environment. Now here's the beauty of Docker. Once we have this image, we can push it to a Docker registry like Docker Hub. Docker Hub to Docker is like GitHub to Git. It's a storage for Docker images that anyone can use. So once our application image is on Docker Hub, then we can put it on any machines running Docker. This machine has the same image we have on our development machine, which contains a specific version of our application with everything it needs. So we can start our application the same way we started it on our development machine. We just tell Docker to start a container using this image. So with Docker, we no longer need to maintain long, complex release documents that have to be precisely followed. All the instructions for building an image of an application are written in a Docker file. With that, we can package up our application into an image and run it virtually anywhere. This is the beauty of Docker. Next, we're going to see this workflow in action. In this lesson, I'm going to walk you through a typical development workflow. Now, don't try to memorize anything in this lesson because I just want you to see the big picture. So everything I show you in this lesson, we're going to cover in depth later in the course. So here in this terminal window, I'm currently on my desktop. I'm going to create a new directory called Hello Docker, then go inside this directory and open it in Visual Studio Code. So I'm going to use VS Code as my editor, but you can use any editor that you prefer, okay? Now in this directory, I'm going to add a new file called app.js. We're going to write one line of JavaScript code. You don't have to be a JavaScript developer. You don't even need to learn JavaScript. So just follow along with me. So here we're going to write console in lowercase .log hello Docker. So with this, we're going to print a message on the terminal. Let's say this is an application and we want to Dockerize this application. So we want to build, run, and ship it using Docker. So typically without Docker, if you want to ship this application or more accurately, this program to a different computer, on that computer, we need to install Node, and then we can go to the terminal and type node app.js. So we get the output. So here are the instructions for deploying this program. We need to start with an operating system. Then we need to install Node, which is an execution environment for JavaScript code. Next, we need to copy our application files. And finally, we need to run node app.js. So we have to follow 4 steps just for a simple program. What if we were working with a really complex application? You would end up with a complex release document that had to be precisely followed. Now, this is where Docker comes to the rescue. We can write these instructions inside a Docker file and let Docker package up our application. So back to VS Code, we're going to add another file to this project called Docker file. So capital D and all the other letters are lowercase, and this file doesn't have any extensions. Okay. Now, VS Code is asking if you want to install the recommended extensions for Docker. We can go ahead with that. Good. So back to this Docker file. Here we write instructions for packaging our application. So typically we start from a base image. This base image has a bunch of files. We're going to take those files and add additional files to it. This is kind of like inheritance in programming, okay? So what is the base image? Well, we can start from a Linux image and then install Node on top of it, or we can start from a Node image. This image is already built on top of Linux. Now, how do I know these names? Well, these images are officially published on Docker Hub. So if you go to hub.docker.com and search for Node, you can see the official Node image here. So Docker Hub is a registry for Docker images. Now back to our Docker file. So we start from a Node image. Now, if you look at Docker Hub, you will see that there are multiple Node images. These Node images are built on top of different distributions of Linux. So Linux has different distributions or different flavors used for different purposes. Now here we can specify a tag using a colon to specify which Linux distribution we want to use. For this demo, I'm going to use Alpine, which is a very small Linux distribution. So the size of the image that we're going to download and build on top of is going to be very small, okay? So we start from that image. Then we need to copy our application or program files. For that, we use the copy instruction or copy command. We're going to copy all the files in the current directory into the app directory into that image. So that image has a file system, and in that file system, we're going to create a directory called app, okay? Now, finally, we're going to use the command instruction to execute a command. What command should we execute here? Node app.js. But this file is inside the app directory, so we have to prefix it with the directory name. Alternatively, here we could set the current working directory, workdir, to /app, and then we don't need to prefix this with the directory name. So when we use this instruction, all the following instructions assume that we're currently inside the app directory, okay? So these instructions clearly document our deployment process. Now, we go to the terminal and tell Docker to package up our application. So we say Docker build. We need to give our image a tag to identify it. So -t. Here we specify a name like hello Docker. And then we need to specify where Docker can find a Docker file. So we're currently inside hello Docker directory, and our Docker file is right here. So we use a period to reference the current directory. Let's go with that. Now, you might be expecting an image file inside the current directory. But back in VS Code, look, there is nothing here because the image is not stored here. And in fact, an image is not a single file. How Docker stores this image is very complex, and we don't have to worry about it. So back to the terminal. To see all the images on this computer, we type Docker images or Docker image ls, which is short for list. So take a look. On this machine, we have a repository called hello Docker. In this repository, we have an image with this tag, latest. So Docker added this by default. We'll talk about this later in the course, but basically we use these tags for versioning our images. So each image can contain a different version of our application, okay? Now, each image also has a unique identifier. Here we can see when the image was created and the size of this image. So because we used Node from Linux Alpine, we ended up with 112 megabytes of data in this image. So this image contains Alpine Linux, Node, and our application files. And the total size is 112 megabytes. Now, if we used a different Node image that was based on a different distribution of Linux, we would end up with a larger image. And then when deploying that image, we would have to transfer that image from one computer to another. So that's why we use Node Alpine, because this is a very small image, okay? So we have built this image. Now we can run this image on any computer running Docker. So on this machine, which is my development machine, I can say Docker run and then type the image name, hello Docker. And it doesn't matter which directory I'm in because this image contains all the files for running our application. Now look, we see the message on the terminal. Now I can go ahead and publish this image to Docker Hub so anyone can use this image. Then I can go on another machine like a test or a production machine and pull and run this image. In fact, I've done this before recording this video. So back to Docker Hub, look, I have this repository code with mosh hello Docker. Now we can take this image and run it on any computers. Let me show you something really cool. So let's search for play with Docker. Let's go to this page and log in. Here we need to sign in with our Docker ID. Anyone can create this ID on docker.com. So let's go ahead and start a lab. Over here, we can start a new virtual machine. So let's add a new instance. Now, this virtual machine is a blank machine. It only has an operating system, which is Linux, and Docker. So in this terminal window, if we type node, look, node command not found. So node is not installed here. But because we have Docker, we can pull and run the image that I published on Docker Hub. So let me maximize this window by pressing Alt and Enter. First, let's run Docker version. So on this machine, we're running Docker version 20.10.0. So to pull and run my program, first we type docker pull code with mosh / hello-docker. All right, Docker downloaded this image. We can verify it by typing docker. What command should we run here? Docker images or image ls. So on this machine, we have this repository, code with mosh / hello-docker. And this repository contains a single image with this tag, latest. So now we can run this application exactly the same way we ran it on my development machine. So from any directory, we can type docker run code with mosh / hello-docker. And here's the message, beautiful. Of course, I had to cut this down in editing. It took a little while to start this application on this very slow virtual machine, but you got the point. So we can take any application and Dockerize it by adding a Docker file to it. This Docker file contains instructions for packaging an application into an image. Once we have an image, we can run it virtually anywhere, on any machine with Docker. All right, the next step in our journey is the Linux command line. But why Linux? What if you're a Windows user? Well, you still need to know a bit of Linux for a number of reasons. For starters, Docker has its foundations built on top of basic Linux concepts. So if you want to be productive and troubleshoot issues easily, you need to know some of the basic Linux commands. Also, most tutorials online are based on Linux commands. So if you don't understand these basic commands, you're not going to get far. In my opinion, learning Linux is like learning English. I think everybody should know some English these days. You don't need to speak it or write a book in it, but you need to understand it. So unless you're a power Linux user, do not skip this section. It's going to be super easy and extremely useful. So let's jump in and get started. Let's start off this section by talking about Linux distributions, also called Linux distros. So as you probably know, Linux is open source software. And for this reason, many individuals and communities have created their own version of Linux called Linux distributions. Each of these distributions is made to fit specialized needs like running servers, desktop computers, mobile phones, and so on. So we have Ubuntu, which is one of the most popular Linux distributions. We also have Debian, Alpine, which we briefly talked about. It's a very small Linux distribution. We also have Fedora, CentOS, and so on. Believe it or not, there are more than 1,000 Linux distributions out there. Now, most of these distributions support pretty much the same set of commands, but sometimes you might discover differences along the way, so be aware of that. In this section, we're going to use Ubuntu Linux because it's one of the most popular distributions. But if you have a preference for another distribution, that's totally fine. All right, let's see how we can run Ubuntu on this machine. From this lesson, I want you to start taking notes. So watch this video, take some notes, and then after the video, repeat the steps I have shown you, okay? So we go to hub.docker.com and search for Ubuntu. Over here, you can see the official Ubuntu image that's been downloaded more than 10 million times. Let's have a quick look here. So for each image, you can see the command to pull that image onto your machine. Now in this lesson, I'm not going to use the pull command. I'm going to show you a shortcut. So here in the terminal, instead of running docker pull Ubuntu, I'm going to run docker run Ubuntu. Now, if we have this image locally, Docker is going to start a container with this image. Otherwise, it's going to pull this image behind the scene and then start a container. So take a look. See, Docker is unable to find this image locally, and now is pulling it from Docker Hub. Now, what happened? Well, Docker started a container, but because we didn't interact with this container, the container stopped. Let me prove this to you. So if you run Docker PS, we can see the list of running processes or running containers. Look, we don't have any containers running here, but if you type Docker PS-A for all, we can see the stopped containers as well. Let me increase the size of this window so we can see it clearly. Good. So we have two stopped containers. The first one is using the Ubuntu image. This is the one that we just started. And the second one is Hello Docker, which we started earlier in the course. So to start a container and interact with it, we have to type Docker run -it, that is short for interactive. We're going to start a container in the interactive mode. And in this container, we're going to load the Ubuntu image, which we have locally. Good. Now, what we have here is called the shell. A shell is a program that takes our commands and passes them to the operating system for execution. Okay. Now, what we have here is called the shell prompt. Let me break it down for you so it doesn't look mysterious. The first part, root, represents the currently logged in user. So by default, I'm logged in as the root user, which has the highest privileges. Then after the @ sign, we have the name of the machine. So this container has this ID, which is automatically generated by Docker. And in this case, it's like the name of a machine, okay? Then after the colon, you can see /. That represents where we are in the file system. A / represents the root directory. That is the highest directory in the file system. We'll talk about that soon. Then we have a £, and this means I have the highest privileges because I've logged in as the root user. If I logged in as a normal user, instead of a £, we would see a $, okay? So in this shell, we can execute a bunch of commands. For example, we can say echo hello, and this prints hello on the terminal. We can also say, who am I? This shows the current user. So these commands that we're running here, this shell program that I told you about, takes these commands and passes them to the kernel for execution. Now, let me show you something really cool. If we type echo $0, we can see the location of this shell program. Take a look. So that is /bin/bash. So bin is a folder or a directory. And inside this directory, we have a program called bash, which is short for Born Again Shell. So apparently, Steve Bourne is the first person who created a shell program. Bash or Born Again Shell is a reference to Steve Bourne. So bash is an enhanced version of the original shell program, okay? Now, one thing you probably noticed is that in Linux, we use a / to separate files and directories. But in Windows, we use a \. So that's one of the first differences. The other difference is that Linux is a case-sensitive operating system. So if you type echo with a capital E, it's not going to work. Bash tells us echo command not found. So lowercase and uppercase letters are different. And this is not limited to commands. It's applicable everywhere. If you want to reference a file or a directory or a user, pretty much anything, we should always spell it properly with the right uppercase and lowercase letters. Now, one last thing for this lesson. Using the up and down arrows, we can go through the commands we have executed so far. So this is a pretty useful shortcut you need to know because you don't want to type these commands manually all the time, okay? Also, using the history command, we can see all the commands we have executed lately. So take a look. So earlier we used who am I, we also used echo and so on. Now we can replay any of these commands by typing an exclamation mark followed by the command number. So if I type 2, this is exactly like running who am I. Now it's your turn. I want you to pause the video, go through your notes, and execute the commands I have shown you in this video. These days, most operating systems and development platforms come with a package manager. You've probably worked with tools like NPM, Yarn, pip, and so on. Here in Ubuntu, we also have a package manager called apt, which is short for Advanced Package Tool. So let's execute this command. Look, this command has a bunch of subcommands. So using list, we can see the list of packages. We can also search for them. We can show details about the package. We can install, reinstall, and remove a package and so on. Now, technically, apt is the newer package manager. We also have apt-get, which you see a lot in online tutorials. Going forward, we're going to use apt because it's easier to work with. So let's say we want to install a package called Nano. Nano is a basic text editor for Linux. Now, if you press enter here, we get an error because this image, this Ubuntu image we are running, does not have Nano. So this is where we use apt to install this package. So if we type apt install Nano, we get an error saying unable to locate package Nano. Why is this happening? Well, here in Linux, we have a package database, and this database might contain hundreds of packages, but not all these packages are installed. So if you want to see all the packages in this database, we type apt list. Look, these are all the packages. Now, in front of these packages, you can see some of them are installed, but not all packages in this database are installed. When we type apt install nano, this command looks at the package database, and in this database, it cannot find a package called nano. So this is where we use the update command to update the package database. Now, when we press enter, Linux is going to all these sources like security.ubuntu.com and all these other websites to download the list of packages. So now our package database is updated. So if we run apt list, we see far more packages. And as you can see, most of these packages are not installed because we don't have installed in front of them. So now we can run apt install nano, and nano is installed. So here's what you need to take away. Before installing a package, you should always run apt update to update your package database, and then you can install a package like nano. Now we'll talk about nano later in this section. But before going forward, let's make sure that this package is installed properly. So if you type nano, great. So here we have a text editor, we can type something. Let me resize the window. So down below, you can see the shortcuts. To exit, we have to press Ctrl and X. Now it's asking if you want to save the changes. No, so we're going to press N. Good. If you're back here, we can clear the terminal window by pressing Ctrl and L. Okay. So we have installed nano. Now let's say we want to remove it. So we type apt remove nano. It's asking for confirmation. Let's go ahead. Great. So nano is gone. If I type nano, we get this error saying no such file or directory. Now here's a little exercise for you. In this image, we don't have Python, so we get an error. So I want you to use apt to install Python in this image, make sure it works, and then remove it. So in Linux, just like Windows, our files and directories are organized in a tree, in a hierarchical structure. So in Windows, we have a structure like this, with C drive on top of the hierarchy. Then below that, we have directories like program files, Windows, and so on. In Linux, we have the root directory on top of the hierarchy. Below that, we have a bunch of standard directories. For example, we have bin, which includes binaries or programs. We have boot, which includes all the files related to booting. Then we have dev. The first time I saw this, I thought this is short for development. It's not. It's short for devices. So in Linux, everything is a file, including devices, directories, network sockets, pipes, and so on. So the files that are needed to access devices are stored in this directory. Then we have etc. There are different opinions. What is this short for? But one common opinion is this is short for editable text configuration. So this is where we have configuration files. We also have home. This is where home directories for users are stored. So on a machine with multiple users, each user is going to have a home directory here. We also have root, which is the home directory of the root user. Only the root user can access this directory. Then we have lib, which is used for keeping library files like software library dependencies. We have var, which is short for variable. And this is where we have files that are updated frequently, like log files, application data, and so on. And finally, we have proc, which includes files that represent running processes. So once again, in Linux, everything is a file. Processes, devices, even directories are files. Now, you don't need to memorize any of these directories. I just listed them here, so as we go through the course, these directories look familiar to you. That's all. Next, I'm going to show you how to navigate the file system, and there you will see these directories one more time. Let's see how we can navigate the Linux file system. So the first command we're going to talk about is pwd, which is short for print working directory. With this, we can see where we are in the file system. So a / represents the root directory. Now to see the files and directories here, we type ls, which is short for list. So we have bin, which we talked about earlier, that is short for binaries. This is where we have binary files and programs. We have dev, which includes files for devices. We have boot, which includes boot files, etc, which includes configuration files, and so on. Now, by default, ls lists these items on multiple lines. If you don't like this layout and want to show one item per line, you need to pass an option, that is -1. You might prefer this layout. We have another option, -l, for seeing a long listing. This listing includes more details. So in the first column, we have the permissions of this file or directory. The first time you see this, it might look really scary, but trust me, it's easier than you think. We'll talk about that later in this section. Over here, you can see the user that owns this file or directory. We can see the size, we can see the date, and so on. Now, to change the current directory, we use the cd command. We have the same command in Windows. Now here we can type a relative or an absolute path. A relative path is relative to where we are. So in this root directory, we have directories like bin, boot, and so on. So this is a relative path. Now in contrast, an absolute path always starts from the root directory. So let's go to a directory starting with E. Now we can press tab to get auto-completion. Beautiful. Now let's go to a directory starting with A. Now if you press tab, nothing happens because we have multiple directories starting with A. So we have to press tab one more time. Great. So we have 3 entries, 3 directories, add user.conf, alternatives, and apt. So let's type the second letter, P, and then press tab. Beautiful. Now let's see what we have in this directory. So these blue items are directories, and sources.list is a file. Now to get out of this directory, we can go one level up by typing 2 periods. Again, I'm pretty sure you're familiar with this, but I want to cover it to make this section comprehensive. So we can go 1 level up to get to the etc directory, or 2 levels up to get to the root directory. Look, we're currently in the root directory. Now, when using ls, we can optionally specify a path. Let's say I'm somewhere in the file system, but I want to look at the content of another directory. I don't want to navigate to that directory. So I'm currently in the root directory. I want to know what files and directories we have inside the bin directory. So once again, we can type a relative path or an absolute path starting from the root directory. So here are the binaries in this directory. Look at pwd. That's the command that we just executed. So pwd is a program in this directory. Here's another example. Look at echo. So most of the commands we have been exploring so far are programs or binaries in the bin directory, okay? Now let me show you a shortcut. Earlier I told you that here we have this home directory where each user has a home directory, but the root user has a special home directory called root. Now to get here, there are 2 options. We can type an absolute or relative path and go to root, but there is a shortcut. So let me get out of this directory. So I'm currently in the root directory. To get to my home directory, I can type a tilde, and this applies to all users, not just the root user. Whenever we type cd tilde, we go to our home directory. Now, right now, there is nothing here, but in the next lesson, I will show you how to create some files in this directory. So before moving on to the next lesson, I want you to spend a couple of minutes and play with the commands we explored in this lesson. Navigate the file system, get adventurous, see what you can discover. I'll see you in the next lesson. Let's see how we can manipulate files and directories. So I'm currently in the root directory and I want to go to my home directory. How can I do that? Do you remember? We type cd tilde. Great. Now, in this directory, I want to create a directory called test. So we type mkdir test. Let's verify. It's right here. As I told you before, blue represents a directory. Now, let's say we want to rename this directory. How do we do that? We use the move command. With this, we can rename files and folders or move them somewhere else. So we can move or rename test to Docker. All right, beautiful. Now let's go in this directory. Now to create a new file, we use the touch command. So we can create hello.txt. Look, we have this new file here. This is a new empty file. In the next lesson, I will show you how to edit files. So for now, don't worry about it. Also, using the touch command, we can create multiple files in one go. So we can create file 1, file 2, and file 3. Now take a look. Beautiful. Now I've got a question for you. How do we list these files with a single file per line? Do you remember? We type ls-1. Now let's say we want to rename hello.txt to something else. Once again, we can use the move command. So we type H, press tab to get auto completion. We can rename this to hello-docker.txt, or we can move it to a different directory. For example, we can move it to the etc directory. And here I'm using an absolute path because my path has started from the root directory. Now in this lesson, I don't want to move this anywhere. So I just want to rename this to hello-docker.txt. And if you're wondering how I remove this entire word in one go, I press Ctrl and W. So let's bring it back. Hello-docker.txt. Take a look. Good. Now let's see how we can remove one or more files. To do that, we use the rm command. Now here we can type one or more files. So we can say file1.txt, file2.txt, or we can use a pattern. For example, I can say, I want to remove all files that start with file. Let's verify it. Beautiful. We only have hello docker. Now, let's get out of this directory and remove the directory itself. So we type rm docker. Now we get an error saying Docker is a directory. So to remove directories, we have to use the R option, which is short for recursive. So we want to remove this directory and all its content recursively. Now we press D, tab, beautiful. So let's verify there's nothing here. So let's quickly recap. We use mkdir to create a new directory. We use touch to create a new file. We use move to move or rename files or directories. And we use rm to remove files and directories. Now, as an exercise, go to your home directory, create a bunch of files and directories, rename them, and then remove them. In the next lesson, I'm going to show you how to view and edit files. All right, let's see how we can edit and view files. So earlier, we briefly talked about Nano. Nano is a basic text editor for Linux. Now, on this image that we are running, we don't have Nano, so we have to install it. Do you remember the command for installing Nano? That is apt install Nano. All right, now we have Nano, so we can launch it and optionally supply a file name. Let's say file1.txt. So here we have a basic text editor. We can type whatever we want. And when we are done, look down below. The shortcut for exiting is Ctrl and X. So I'm going to press that. Now it's asking if you want to save the changes. So we press yes. And here we confirm the file name. We can keep the same file or change the file name. Let's go ahead. So now in this directory, we have file1.txt. Beautiful. Now to see the content of this file, we have a few different commands. The simplest one is cat, and this has nothing to do with cats. It's short for concatenate. So later I will show you how we can use this command to concatenate or combine multiple files. But with cat, we can also see the content of a file. So if we say cat file1.txt, we can see the content of this file. Now, cat is useful if our file is short and fits on one page. But if you're dealing with a long file, it's better to use the more command. Let me give you an example. So I'm going to use cat to show the content of this file /etc/adduser.conf. This is a really long file. So if I scroll up, look, we have a lot of text. Now, sometimes you don't want to see all the content in one go. You want to scroll down. You want to go page by page. This is where we use the more command. So more /etc/adduser.conf. Now down below, look, you can see more 15%. So we're seeing 15% of this file. Now, if we press space, we can go to the next page. So now we're at the position 33%. Alternatively, we can press enter to go one line at a time. Now, the problem with more is that we can only scroll down. We cannot scroll up. So to do that, we have to use a different command called less. So to exit here, we press Q. Good. Now, in this image, we don't have less. So once again, we have to manually install it. So apt install less. So less is a newer command that is supposed to replace more. Let's go ahead. Great. So let's look at the same file using the less command /etc/adduser.conf. So now using the up and down arrows, we can scroll down or up. So just by pressing up and down arrows. We also have space. We can go to the next page and enter, just like the more command. And when we are done, we can press Q. Now we have a couple more commands for viewing the content of a file. We have head, which we can use to display the first few lines. So here we can supply an option and say the number of lines we want to see is 5. Let's look at the same file. So this shows the first 5 lines of this file. Similarly, we have tail, which shows the last few lines. So we supply an option and say we want to look at the last 5 files. That's it. So to recap, we can use nano to write something to a file. We can use cat to view the content of small files, less to view the content of long files in an interactive way, and head and tail to view the first few or the last few lines of a file. One of the important concepts in Linux is the concept of standard input and output. So standard input represents the keyboard and standard output represents the screen. But we can always change the source of the input or the output. This is called redirection. Let me show you using a few examples. So we talked about the cat command to see the content of a file. Let's say file1.txt. When we execute this command or this program reads data from this file and prints it on the standard output, which is the screen. That is why we see the content here. But using the redirection operator, which is the greater than sign, we can redirect the output from the screen to, let's say, a different file. So now cat will read the content from this file and write it to this file. Take a look. So we have file2.txt. If we view it, we see the exact same content as file1. Okay. Now, what is the point of this? Well, earlier I told you that we can use the cat command to concatenate or combine multiple files. So here we can say cat file1.txt and file2.txt. If we press enter, cat is going to read the data from both these files and print it on the terminal, which is the standard output. But once again, using the redirection operator, we can write the result to a different file, combined.txt. So this is how we can use this command to combine multiple files. Now, the redirection operator is not limited to the cat command. We can use it pretty much anywhere. For example, earlier we talked about the echo command. If we say echo hello, we see the result on the terminal. But if we say echo hello to hello.txt, now we have a new file here, hello.txt, which contains hello. So if you want to write a single line to a file, we don't have to use nano. We can use the echo command. So echo whatever to whatever file.txt. Okay. Now here's a little exercise for you. I want you to get a long listing of the files in the etc directory and write the output to a file. So pause the video and work on this for a few seconds. So here's the solution. To get a long listing, we type ls-l. Then we specify the path, the etc directory. Now, instead of printing the result on the terminal, we're going to write it to a file called files.txt. Okay. Now let's view this file. Perfect. Now, one more thing before we finish this lesson. Using the greater than sign, we can redirect the standard output, but we also have the less than sign to redirect the standard input. I personally haven't found many use cases for this, so I didn't cover it in this lesson. All right, that's all about redirection. Next, we're going to talk about searching for text in files. Let's see how we can search for a string in a file. So we have this grep command, which is short for global regular expression print. I know it's such a mouthful, but let's say we want to search for the word hello in file1.txt. What happened? Didn't we write hello to file1.txt? Yes, we did, but this search is case sensitive, just like everything else in Linux. If you want to remove case sensitivity, we have to use an option. That is -i. So case insensitive, okay? Now we see the word hello highlighted in red. Let's look at another example. This time, I want to search for the word root in /etc/password. This file contains the list of user accounts on this machine, not their passwords, just their accounts. So take a look. On this line, which I think is the first line in this file, we have 3 occurrences of root, and that's why they're displayed in red. Now, we can also search in multiple files. So let's search for hello in file1.txt and file2.txt. That's one way. We can also use a pattern. So we can say we want to search in all files whose name starts with file. So we use a wildcard here. Now you can see in file1.txt we have hello, and the same is true in file2.txt. Now we can also search in a directory. So instead of typing a file name, we can type a directory name, or we can use a period to refer to the current directory. Now we get an error saying period is a directory. So here we have to use an additional option, -r, which is short for recursive. So with this, we can search this directory and all its subdirectories recursively. Now look, in all these files, we have references to hello. Now, one last thing. In Linux, we can combine multiple options. So instead of having 2 different options, -i and -r, we can combine them into one option. This gives us the exact same result. So using the grep command, we can search for a string in 1 or more files. Let's talk about finding files and directories. So I'm currently in my home directory, as you can tell from the tilde. Let's run ls. So here we have combined file1, file2, files, and hello.txt. Now, of course, on your machine, you might have different files. It doesn't matter. Now, in Linux, we have the find command for finding files and directories. If we execute this command without any arguments, we see all the files and directories in the current directory recursively. So this command is going to go through every directory in this directory and list their files. So on the top, we have .bashrc and .profile. These are 2 hidden files in the current directory. You didn't see this earlier when I executed ls, because by default, ls doesn't show the hidden files and directories. Now, what option should we use to see the hidden files and directories? Do you remember? -a, which is short for all. So now you can see bashrc, profile, and local, which is a directory because it's blue. So back to the find command. Here you can see all the files and directories in the current directory. Now, if you want to look somewhere else, we can supply a path. So we can search in the etc directory. Now we can see all the files and directories starting from etc. Okay? Now, let's get back to the current directory. Let me show you various ways to filter the result. If you want to see only the directories, we pass an option called type with the value of D. Now you can see only the directories in the current directory. Alternatively, we can search for files. We can also filter by name. So let's say I want to find all the files whose name start with, let's say, F. Here in double quotes, we can type a pattern. We can say F star. Now just remember that this search is case sensitive, just like everything else in Linux. So if you type a capital F here, we don't find anything. Now to make the search case insensitive, instead of name, we use a different option that is iname. All right, beautiful. Now here's a little exercise for you. Using the find command, I want you to find all the Python files in this image and then write the result to a file called pythonfiles.txt. So pause the video, work on this for a few seconds, then come back see my solution. All right, so using the find command, we're going to look at all the files starting from the root directory. Now, we're going to supply an option, type F. So we only look at files. We're going to supply a second option for searching by name. Here I'm going to type a pattern like star.py because all Python files have the py extension. Now, if you didn't know this, don't worry, it doesn't really matter. So this way, we can find all the Python files in this image. Let's verify it. Beautiful. Now, to write the result to a file, we're going to use the redirection operator. So we can write it to a file called pythonfiles.txt. Good. Now, let's verify that everything is working. Beautiful. In Linux, we have a few different ways for chaining or combining multiple commands. So once again, I'm in my home directory. Let's say I want to create a directory called test. And right after this, I want to go into this directory and echo something to the terminal. Now, I don't want to press enter here and then type the second command. I want to type multiple commands and execute them in one go. So here we type a semicolon and then type the second command, which is cd test. Now, once again, we type a semicolon and type the third command. So echo done. Now, if I press enter, all these commands will get executed one after another. Now, some people prefer to add a space around these semicolons to make their command sequence more clear, more readable. That's optional. It's entirely up to you. So look, we see the done message and we're currently inside the test directory. Now, if we go one level up and execute the last command, we're going to get an error because we already have the test directory. But the other two commands will get executed. Take a look. So look, here's the error saying the test directory exists, but we also see the done message and we're currently inside the test directory. Now, what if you want to stop execution? So if one command fails, the other commands are not going to get executed. Well, this is where we use the AND operator. So let me go up and clear the screen. Now, instead of a semicolon, we're going to use double ampersands. That is the AND operator. So if this command fails, the other commands will not get executed. Take a look. All right, we saw an error saying the directory exists, but we're still inside the home directory. We didn't go inside the test directory. Now we also have the OR operator. So if we say create the test directory or echo directory exists, if this command gets executed, this command will not get executed. But if this command fails, this command gets executed. Make sense? So essentially it's saying create this directory or print directory exists. Let's try it. So we got this message because the directory already exists. But if I bring up this command and change the directory name to test2, this time we are not going to see this message because we can successfully create this directory. There you go. So these techniques are very powerful. You'll use them a lot when it comes to deploying your applications using Docker. You'll see more examples in the future. Now, another way to chain commands is piping, and this is extremely powerful. So let's look at the content of the bin directory. So here we have a long list of files, but what if you want to look at this list using the less command? So remember, earlier we talked about the less command. With this, we can look at the content of a file, and then we have the ability to scroll up and down or go line by line and then quit. This is where we can use piping. So we use the ls command, get the content of the bin directory, and then create a pipe. So we get the output of this command and then send it to the less command. So essentially we're creating a pipe. What comes out of this command goes into the second command. So now less doesn't need a file name because it gets the input from the first command. Take a look. So now we're seeing the output of the less command. Using the up and down arrows, we can scroll. Using space, we can go to the next page, and then we can exit using Q. We can also use the head and tail commands here, pretty much any commands. So if we use head, by default, we can see the first 10 lines. We can supply an option and see the first 5 lines. Pretty useful. Now, one last thing before we finish this lesson. Sometimes when dealing with a long command, our command sequence might look a little bit hard to read. So let me show you how you can split it into multiple lines. So I'm going to create a directory called hello. Then I'm going to go into this directory and echo done. Now, this is a fairly short command, but imagine this was really long and we had to scroll horizontally. We don't want to do that. So we create a directory and then terminate this command using a semicolon. Now, if we type a backslash and press enter, we go to the second line and the command prompt changes. So we can type the rest of the command here. Now we're going to go to the hello directory, then terminate this command and add a backslash. So on the third line, we can echo done. And of course, we can keep going as much as we want. So this is how we can break up a long command into multiple lines by using a backslash. There you go. Let's talk about environment variables. This is one of the areas that a lot of people are confused about. So just like we have variables in our programming languages, in Linux, we have environment variables which we can set for storing configuration settings for our applications. So our applications can read configuration settings from these environment variables. In this lesson, I'm going to show you a few different commands for viewing all these environment variables and setting them. So the first command is printenv. With this, we can see all the environment variables in this machine. Take a look. So let me scroll up. All right. So here we have a bunch of key value pairs separated by an equal sign. The first variable is hostname, which is set to the ID of our container. And as you know, this is generated by Docker automatically. Then we have pwd, home, ls colors, and so on. Now down below, we have a very important environment variable called path. Have you noticed that sometimes when you run a program from the command line, you get an error saying the program or the command was not found, even though you have installed that program? Quite often that happens because your operating system, whether it's Linux or Windows, cannot find that program. Now, here's the interesting part. To find a program, your operating system is not going to go through your entire hard drive. It's only going to look at specific directories. And those directories are specified using the path variable. So this is set to a list of directories separated by colon. So here's the first directory. Then we have a colon. Here's the second directory, and so on. These are the directories that Linux or Windows searches for to find a program or a command. Okay? Now, what if you want to see the value of a particular variable? We can type printenv and then path. That's another way. Now, once again, everything is case sensitive here. So if I type path in lowercase, we're not going to see anything. Okay? Now, there's another way to see the value of an environment variable. Instead of printenv, we can use echo, but here we have to prefix the variable with a $sign. So Linux knows that we are referring to an environment variable, like path. Now, how can we set a variable? Using the export command. So let's define a variable called db_user, and I'm going to set that to mosh. Now this variable is stored in the current session, in the current terminal session. So we can read it using the echo command, db_user. We can also read it using printenv. However, this variable is only available in the current terminal session. So if I close this terminal session and open a new terminal session, this variable will not exist. Let me show you. So we can terminate this session by typing exit. Now we're outside of our container environment. So we're back on my Mac terminal. Now let's run docker ps to see all the Docker processes or containers. There's nothing here. Our container is stopped. Now to see all the containers, including stopped containers, we type docker ps-a, that is short for all. So let me expand this window so you can see clearly. So we have two stopped containers. One was running our Ubuntu image, and the other was running Hello Docker. This container was the one that we have been working with throughout the section. Now I want to start this container so we can work with it again. So just like virtual machines, we can stop or start a container, okay? So look at this container ID, 2F whatever. I'm going to grab the first few letters, 2F7. So to start this container, we type docker start. We use -i so we can interact with it, and then type the container ID. Quite often, we can type only the first 2-3 letters, unless there is another container whose ID starts with the same sequence of characters. Then we have to type more characters, okay? So let's start it again. We are back in the same Linux machine. Now if we type echo db_user, we don't see anything because that variable does not exist anymore. It was only available in that terminal session. Now, to make it persistent, we have to write it to a special file. So we go to our home directory. Now we list all the files, including hidden files. Earlier you saw this file, bash rc. This file is a user's personal startup file. So every time a user logs in, Linux loads this command from the user's home directory. So this is where we have to write permanent environment variables. Now we can edit this using nano, so nano.bashrc, but let me show you another technique. Earlier we talked about redirection. So using echo, I want to write something to this file. I want to set db_user to mosh, and then I want to redirect the result to .bashrc. Don't execute this yet, because if you do this, you will overwrite the entire bashrc file. We don't want to overwrite it here. We want to append something to it. So we add another greater than sign, and this will append db_user to bashrc. Okay. Now to verify our work, let's look at bashrc. So take a look. The last line contains our permanent environment variable. And of course, we can always come back and change this value. Now, one thing I want to emphasize here is that you should never store sensitive information in environment variables, because at the end of the day, these variables are stored in plain text files. So we don't want to store DB password here, because anyone who has access to this machine can read the DB password. So just be aware of this. I think most software engineers have made this mistake at least once in their career, and I'm no exception. So we have set db_user permanently in this file. Now, if we exit and open a new terminal session, we can still read the value of that variable. So let's look at all the stub containers. Here's our container. We're going to start it one more time. Docker start -i 2f7. We're back here. So let's echo db_user. Beautiful. Now, one last thing before we finish this lesson. The changes we make to bashrc file are only effective in the next terminal session. So if you write another environment variable here, that variable is not going to be available until we open another terminal session. Let me show you. So let's go to my home directory and echo, let's say, color equals blue. We're going to write that to .bashrc file. Now, if I echo color, look, that variable is not there, even though we wrote it to this file, because this file is loaded only once when we start a terminal session. So now we have two solutions. We can terminate the session and come back in, or we can use the source command to reload the bashrc file. So source.bashrc. And we have to execute this from our home directory. If we are not in our home directory, we can type source home directory /.bashrc. Good. Now let's echo color. And here's the result. Beautiful. Let's talk about processes. Do you know what's a process? A process is an instance of a running program. To see all the running programs or all the running processes, we can use the ps command. So we have two processes. One is running bash, the other is running ps. Now, technically, ps was a very short-lived process. It only existed while this command was producing this output. So now it doesn't exist anymore. However, if we run ps one more time, we see ps again, because once again, while ps was preparing this command, it was being executed, okay? So technically, the only process that is running right now is bash. Do you remember bash? Bash is short for Bourne Again Shell. It's the program that we're interacting with here, the program that takes our commands and sends them to Linux for execution. That's bash. Now, as you can see, each process has a unique identifier that is generated by the operating system. Now, what is TTY? That is short for teletype. And over here, we can see the type of terminal the user is logged into. So PTS is short for pseudo terminal. Don't worry about what it really means. There is some long history, but a short explanation is that this kind of terminal window that we are using, this is called a pseudo terminal. So PTS/0, that represents the first terminal window. So if I open another terminal window and start this container and then execute the same command, we're going to see PTS/1. So in this column, we can see which terminal the user is logged into, okay? Now, time is the amount of CPU time each process consumed. So both these processes are very lightweight. They're not taking much of CPU time. but sometimes you notice your system getting slow. That's because some process is taking so much of CPU time. In that case, you want to kill that process. Let me show you how to do that. First, I want to create a process and put it in the background. So in Linux, we have the sleep command. If I type sleep 3, now the prompt sleeps for 3 seconds and then wakes up. Now, what if you want to put this in the background so we can execute other commands? We append an ampersand here. Now this is in the background and we can execute other commands. So let's run sleep with a longer wait, let's say 100 seconds. And we want to put this in the background. Now, if we run ps, we can see the sleep command. As you can see, this command is not taking much of CPU time. So it's a light process. But let's say we want to kill this. This is where we use the kill command. And here we specify the process ID for the bad boy. So that is 38. Now that is gone. So let's run ps one more time. That process is terminated. Beautiful. All right, let's talk about managing users. So in this lesson, I'm going to show you how to create a new user and then log in as that user. It's going to be fun. So in Linux, we have this command user add for adding a new user. We also have user mod for modifying a user and user del for deleting a user. So we're going to call user add. Now let's look at the options. Here we have a bunch of options and none of them are mandatory. We can use them based on our needs. In this lesson, I'm going to use an option, this one. Each option, as you can see, has 2 forms. The short form with 1 hyphen and the long descriptive form with 2 hyphens. Different people have different preferences. So with this option, we can create the home directory for this user. So we're going to say user add -m, and the name of the user is John. Okay, where is this user? Well, this user is stored in a configuration file in the etc directory. So using cat, we can look at that, cat/etc/password. Now, the name is misleading. Passwords are not stored here. We only have user account information. So take a look. So down below, look over here, we have John. So we have multiple fields separated by a colon. First, we have the username. Then we have a colon as a separator. X means the password is stored somewhere else. I'll show you that in a second. Then we have this field. That's the user ID. Now on your machine, you're probably going to see 1000 because prior to recording this video, I created another user, Mosh, and the ID of that user is 1000. So John's ID is 1001. Then we have the group ID. We'll talk about this in the next lesson. Now over here, we have the home directory of this user. So /home/John. And then we have the shell program used when this user logs in. So /bin/shell represents the old original shell program. But we also have bash, which is born again shell, which is the enhanced version of this program. Okay. Now let's say when I log in, instead of using shell, I want to use bash. So we're going to use user mod to modify this record. So let's look at user mod. The option that I'm going to use in this lesson is -s or shell. This is for setting the shell for this user. So we're going to say user mod -s. Now which shell we're going to use? /bin/bash. Which user? John. Okay. Now let's look at etc/password one more time. So look over here. We have John's record and his shell program is bin/bash. Beautiful. Now, where are the passwords? Well, in the same directory, we have another file that is shadow. So this is where passwords are stored in encrypted format. I don't know how this really works, but just be aware of this file. This file is only accessible to the root user. Okay. Now let's say we want to log in as Mosh. How do we do that? So we open up a new terminal window to log into our container as John. First, we run docker ps to see the running containers. So here's our container ID. Now we're going to execute a bash session inside this container. So we type docker execute, then we paste the container ID, or we can type the first few letters. Okay. Now we want to run a bash session here. Now if I press enter, nothing happens because we didn't interact with bash. So we have to specify -it interactive. Okay. Now, if we run this, we'll log in as root. So now we have two batch sessions. One is in this window, the other is in this other window, okay? Now, we don't want to log in as root. We want to log in as John. So let's terminate this session one more time. You're going to execute a batch session in this container, but before the container name, we're going to supply another option for specifying the user. So -u, which user? John. Now I've logged in as John. You can see that. So John add, and here's the container ID, which acts like the host name. Now look at the prompt. Here we have a $sign, which means I'm not a root user. I'm just a regular user. In contrast, in this other window where we logged in as root, we have a pound. So here we have extra privileges. So back to John's window, let's see what happens if I try to access the shadow file. So cat/etc/shadow. We get a permission denied error. So this verifies that I'm not a root user, okay? Also, John has a home directory. So if we type cd tilde, we go to John's home directory. Let's look at the path for this directory. So that is home/John. So in this directory, we can store John's files. And when we are done, we can remove John by typing userdel John. Now, I'm not going to delete John because in the next lesson, we're going to add John to a group. So we're going to keep him for now. Now, one last thing before we finish this lesson. Back to our first window with the root user, we talked about user add. Now, we also have another command that is add user. What is the difference? Well, user add is the original API that was built, but add user is a Perl script that is more interactive and uses user add under the hood. Let's look at it real quick. So I'm going to execute add user and say Bob. So let's see what's going on here. We see a few messages, adding new user Bob, adding new group Bob. So every user that is created is automatically placed inside a group with the same name. So here we can see the group was created and then this user was inserted in this group. Next, we can see the home directory was created and some files were copied. I don't really understand what that means, but here we have a chance to set the password. So this is what I meant by this command is more interactive than the old command. So here we can set the password and then confirm it. And then we can specify additional information about this user. For example, we can specify the full name, we can specify the room number, work phone, and so on. So this is the difference between add user and user add. Quite often, when using Docker for deploying our application, we don't want to use add user because we don't want to interact with this command. So we want these commands to be executed under the hood. So be aware of the differences between these two commands. Next, we're going to talk about managing groups. So we created a new user in the last lesson. Now let's talk about managing groups. So in the last lesson, we talked about 3 commands that start with user. We have user add, user mod, and user del. We have similar commands for managing groups. So we have group add, group mod, and group del. So let's add a new group called developers. Now, why do we need groups? You probably know this, but we use groups so all users in the same group have the same kind of permission, okay? So now we have a new group. Where is this group? It's in a file in the etc directory. So cat/etc/group. Here are all the groups in this image. So down the bottom, you can see the group of developers, and this is the ID of this group, 1003. Now we want to add John to this group. How do we do that? Let's bring up user mod. So here we have an option for setting the group. Here it is. Again, we have a short form with a capital G and a long form that says groups. With this, we can set the supplementary groups for this user. But we also have another option with the lowercase g or GID that is for setting the primary group of the user. So what is the difference? Well, every Linux user has one primary group and 0 or more supplementary groups. Now, why are these groups separated? Well, let's say John is part of 5 groups, and now he wants to create a new file. Every file, as I will show you in the next lesson, is owned by one user and one group. Here's the question. If John is part of 5 groups, which group should we use for owning that new file that John is going to create? That's why we need a primary group. Now, the primary group is automatically created when we create a new user. It's the group with the same name as the user. So here, I'm going to use this other option to set the supplementary groups for John. So we say usermod dash capital G. Now here we type the group name, that is developers, and then we add John to this group. Great. Now let's look at the password file one more time. So cat/etc password. Now what if we only want to see the record for John? We can use piping again. So here we can use grep and search for John. That's one way. Another way is to use grep and search for John in etc/password. So in this record, I told you that this is the user ID for John, and this is the group ID. This is the ID of John's primary group. Now, where the secondary groups are stored, I can't recall on top of my head, and it doesn't really matter. We actually have a command for seeing the groups of a user. We type groups and then the name of the user, so John. So John is currently part of two groups. One group is John, which is John's primary group, and the other one is developers, which is a supplementary group, okay? Now, of course, we can add John to more supplementary groups, and that's what I want you to do as an exercise. So pause the video, add John to a new group called artists. In the next lesson, we're going to talk about file permissions. All right, the last thing we're going to talk about in this section is file permissions. This is one of those areas that a lot of people find confusing or complicated. It's actually very easy. Let me make it super simple for you. So I've logged in as root and I'm in my home directory. Let's go to the home directory. And in this directory, I want to create a file called deploy.sh. Files with this extension are called shell scripts. In these files, we can write any of the Linux commands you have learned so far. So we can combine all these commands and create a deployment script. Okay. So to write to this file, I'm going to use the echo command. I'm going to write echo hello to deploy.sh. So I'm writing this line to this file. Let's go ahead. And now let's verify it. So we have echo hello. So when we execute this file, we're going to see hello on the terminal. Okay. Now to see the permissions for this file, we have to get a long listing. Take a look. So in this directory, we have 3 directories, Bob, John, and Mosh, and 1 file. Now in the first column, we can see the permissions for each item. Now look at the first letter. If the first letter is D, that means this is a directory. If it's a hyphen, that means this is a file. Pretty straightforward. Now what about the other letters? Well, these letters, they're actually 9 letters divided into 3 groups. Here's the first group, then we have the second group and the third group. In each group, we have read, write, and execute permissions. So for this item, for deploy.sh, for this file, we only have read and write permissions, but the execute permission is missing because we have a hyphen. Now in contrast, look at the permissions for this directory. We have read, write, and execute. Execute is used so we can go into that directory. So we can use the cd command with it. So by default, all directories have the execute permission. Now, in the second group, we only have the read permission. And this is true for the third group. But what are these groups for? Well, the first group represents the permissions for the user who owns this file. That is the root user here. The second group represents the permissions for the group that owns this file. And that is this group. So by default, every user that is created is automatically placed inside a group with the same name, okay? Now, the third group represents permissions for everyone else. Now, to execute this file, we have to type period, referring to the current directory, then /deploy.sh. We get a permission error because even I, as the root user, do not have the execute permission on this file. This is where we use the change mode command. So we type chmod. Then here we can change the permissions for the user that owns the file, or the group, or others. For the user, I'm going to add the execute permission. If I want to remove the execute permission, I would have to use a hyphen, okay? So we want to add the execute permission to where? To deploy.sh. Now, let's get the long listing one more time. Look at the color of this file. It turned green because now it's executable. Now look at the first group. We have read, write, and execute. So I can call deploy.sh and we see hello on the terminal. Beautiful. Now, with this setup, the root user is the only user who can execute this file. So if we go to this other window where I've logged in as John, we're currently in John's home directory. So let's go one level up. Now we are inside the home directory of all users. And over here, we have the deployment script. But if we try to execute this file, we get a permission error. So how do we enable John to execute this file? Well, back to our first window. We're going to use chmod one more time. This time, we're going to apply the permission for others. We want to enable the execute permission to deploy.sh. Good. Now, back to John's window. We can call deploy.sh and we see hello on the terminal. Beautiful. So this is how we can change permissions for files. Now, let's talk about variations of this command. So we can also combine groups. So we can say OG, that means others, and the group that owns this file. It's not short for original gangster. So for others and the group owner, we can add the execute permission. We can also add the write permission, and we can remove the read permission. So this is the syntax to use this command. And of course, we don't have to type a single file name. We can type multiple file names or use patterns. For example, we can apply these permissions to any files with the shell extension. So we're done with this section. I hope you've learned a lot. With the foundation that you have built in this section, now you're ready to learn Docker the right way. So I will see you in the next section. The first step in using Docker to build and deploy applications is creating images. So having a solid understanding of Docker images is crucial for you. And that's what this section is all about. We'll be talking about creating Docker files, versioning images, sharing them, saving and loading them, and a few optimization techniques for reducing the image size and speeding up builds. I'm so excited about this section. I hope you are too. So let's jump in and get started. All right, before we get started, let's make sure you have the right understanding of images and containers. Can you define what an image is and how it's different from a container? Pause the video and think about it for a few seconds. Here's the answer. An image includes everything an application needs to run. So it contains a cut-down operating system like Linux or Windows. It also contains third-party libraries, application files, environment variables, and so on. So an image contains all the files and configuration settings needed to run an application. Once we have an image, we can start a container from it. A container is kind of like a virtual machine in the sense that it provides an isolated environment for executing an application. And similar to virtual machines, we can stop and restart containers. Now, technically, a container is just an operating system process, but it's a special kind of process because it has its own file system, which is provided by the image. Now, let me show you something interesting. In the previous section, we started a container from the Ubuntu image, right? Now I'm going to open up another terminal window. Let's run Docker PS to see the running processes or running containers. So here's the container that we started in the previous section. Now I'm going to start a new container from the same image. Let's see what happens. So do you remember how to start a container from an image? We type docker run. We want to run this in the interactive mode so we can work with it. And then we type the name of the image, so Ubuntu. All right, here's the container ID. And as you can see, this is different from this other container. Now, back to our first container. I'm currently inside the home directory. So in the previous section, we created a bunch of directories and this deployment file. Now, back to our new container, let's go to the home directory and see what is here. There is nothing here. Here's the reason. A container gets its file system from the image, but each container has its own write layer. So what we write in a given container is invisible from other containers. Of course, there is a way to share data between containers, and we'll talk about that later in the course. But what I want you to understand here is that each container is an isolated environment for executing an application. It's an isolated universe. So whatever happens inside that universe is invisible to other containers, okay? Now that you have a proper understanding of images and containers, we're ready to Dockerize an application. So in the next lesson, we're going to take a front-end application built with React and start Dockerizing it. So over the next few lessons, we're going to take a front-end application built with React and package it into a Docker image. I've attached this application below this video, so go ahead and download the zip file, then extract it somewhere on your machine. Now, I want to emphasize, you don't need to know React or even JavaScript to go through this course, because Docker is not about JavaScript or React. So if you're a C# or Java or a Python developer, you can still go through the course and learn a lot about Docker. In this course, we're only going to take this application as an example so we can learn about Docker. Now, let me give you a quick overview of what we have in this project in case you are not familiar with JavaScript or React projects. So in this project, we have this file package.json, which is basically like an identification card for our application. So on the top, we have the name and the version of our application. And over here, we can see the dependencies of this application. These are the third-party libraries that our application needs to run. Now, let's say we want to take this application and run it on a brand new machine. So on this machine, we don't have anything but an operating system. Whether it's Windows or Linux, doesn't matter. So there are a number of steps we have to follow. Take a note of this. First, we have to install Node. Once we have Node, then we can use Node's package manager or NPM to install the dependencies of this application. When we run this command, NPM is going to look at package.json. Then it's going to automatically download and store all these third-party libraries in this project. So let's go ahead. This is going to take a few seconds, so I'll be right back. All right, back to our project. Now we have a new directory called Node Modules. In this directory, you can see all the dependencies of this application and their dependencies. So this is a very large directory with hundreds or even thousands of subdirectories, okay? So let's quickly recap. To run this project on a new machine, first we have to install Node. Then using NPM, we have to install third-party dependencies. And finally, to start the project, we have to type npm start. We have the same concept in other development stacks. So whether you use C# or Java or Python or Ruby, you have some tool to manage the dependencies of your application, and then you have a way to start your application. Here we have to use npm start. So let's go ahead. This started a development server listening on port 3000. So if you go to localhost port 3000, we can see our React application. This is just a basic React application, like a brand new project. I haven't done anything here, and it doesn't really matter. Later in the course, I'm going to show you a real project that I have built using React and Node. So now that you understand what this project is and how we can run it on a new machine, let's see how we can use Docker so we don't have to repeat all these steps every time we want to deploy this on a new machine. So throughout the rest of this section, we're going to Dockerize this application and package it into an image. Once we have that image, we can deploy this application virtually anywhere. The first step to Dockerize an application is adding a Docker file to it. Do you remember what a Docker file is? It contains instructions for building an image. You saw a few of these instructions before, but let's go through the complete list so you know what is available. We have from for specifying the base image. So we take that base image, which contains a bunch of files and directories, and then we build on top of it. Then we have workdir for specifying the working directory. Once we use this command, all the following commands will be executed in the current working directory. We have copy and add for copying files and directories. We have run for executing operating system commands. So all the Linux commands that we talked about in the previous section, you can execute them using run. Now, if you're on Windows, you can execute Windows commands using run as well. We have env for setting environment variables, expose for telling Docker that our container is starting on a given port, user for specifying the user that should run the application. Typically, we want to run our application using a user with limited privileges. And we have command and entry point for specifying the command that should be executed when we start a container. So that's the big picture. Now, over the next few lessons, we're going to explore each of these commands in detail. All right, let's start off by adding a Docker file to this project. So here in the root of this project, we're going to add a new file called Docker file. Now, the first instruction we're going to use is from, which we use for specifying the base image. The base image can be an operating system like Linux or Windows, or it can be an operating system plus a runtime environment. For example, if you're a C# developer, you want to start from a .NET image. If you're a Python developer, you want to start from a Python image. If you're a JavaScript developer, you want to start from a Node image. Now, if you Google Docker samples, you can find this page, docs.docker.com/samples. Over here, you can see various examples of Docker files for different technology stacks. For example, for an ASP.NET Core application, you can see a Docker file right here. Now look at the from instruction. Over here, we have a full URL instead of an image because Microsoft images are not hosted on Docker Hub. They're hosted in Microsoft Container Registry. That's why we have MCR, which is short for Microsoft Container Registry. So an image can be in any registries. The default registry that Docker uses is Docker Hub. For any images in other registries, we have to type the full URL, okay? Now, don't just blindly take this URL because the URL can change or the version can change. So always do your own research. So that's one example. If you're a Django developer, you want to start from Python 3. Or in the future, you might want to use Python 4. Now, what about this project? Well, for this project, we need Node because as you saw, we need npm to install the application dependencies and start the application. So let's go to hub.docker.com and search for Node. Now, this is where things get a little bit interesting because Node repository on Docker Hub has hundreds of Node images, and this can be a little bit confusing. So let's go to the tags. Here you can see various Node images. So if you scroll down, you can see there are tons of Node images for different versions built on different versions of Linux. For example, we have Node version 14.16.0 on top of Buster, which, if I'm not wrong, is Debian Linux version 10. So we have different versions of Node on different versions of Linux. The image you should choose really depends on your application. What version of Node do you want to target? We can go to our Docker file and say you want to start from Node, and by default, Docker assumes the latest tag. Do not ever use this because if you build your application against the latest version of Node, next time there is a new version of Node, if you rebuild your application's image, your application will be built with a different version of Node, and things can get unpredictable. So always use a specific version. So back to Docker Hub. Let's say I want to build this application against Node version 14. So here we search for 14. Now, once again, we have tens or maybe hundreds of Node images for version 14. Here's one we just talked about. There is more. We have version 14 on top of Buster. So this one doesn't have the minor build number. It's just the major version number. Now look at the size of this image. It's around 300 megabytes. And why do we have multiple items in this list? Well, this image is built for different operating system and CPU architectures. So there's two more here. As you can see, all of these are built on top of Linux. So as far as I know, we don't have a Node image built on top of Windows. I could be wrong. But if you want to run on top of Windows, you have to start from a Windows image and then install Node on top of it. There's no reason you want to do this because Windows images are really large. I think they're over 2 gigabytes. So back to the story. Depending on your CPU architecture, when you pull an image, Docker will automatically download the right Docker image for your CPU architecture, okay? Now, I don't want to use any of these images because these are way too large. And this is the compressed size. When this is uncompressed, it's going to be around 1 gigabyte. I want to go for a smaller image because I want to make my builds and deployments faster. So on this page, let's search for Alpine. Earlier, I told you that Alpine images are really small. Look at this. The compressed size is around 40 megabytes. This image is almost 10 times smaller than the other image you saw. Now look at the image tag. It's very specific. Version 14.16.0 of Node built on top of Alpine 3.13. I'm happy with this version, so I'm going to copy this and then paste it here. Okay, so that was the first step. Now back to our terminal window. Here in the project directory, we're going to build an image. So we run docker build -t for tagging the image. We're going to call this image React app, and we type a period to tell Docker where it can find a Docker file. That means in the current directory. Let's go ahead. Okay, the image is built. So now we're going to look at all the images we have on this machine using Docker images or Docker image ls. So currently we have 3 images. Here's the image that I just built. Now let's start a container with this image and see what happens. So Docker run. We want to run this in the interactive mode so we can play with it. And the image is React app. What's going on here? We're inside a Node environment. So here we can write JavaScript code and Node will execute it. For example, we can define a constant and then log the constant. So we're inside a Node environment. We don't want this. We want to run bash so we can look at the file system. So we press Ctrl and C. Now it says to exit, press Ctrl and C one more time. Good. So the container is stopped. Let's run it one more time. So Docker run interactive React app. Now at the end, we can specify the command to run when starting this container. We want to run bash. Now look, we get an error saying this module is not found. Why is that? Because Alpine Linux doesn't come with bash. That's why it's a very small Linux distribution. So it doesn't have many of the utilities you're familiar with. Instead of bash, it comes with shell, the original shell program. So one more time, Docker run interactive React app. Instead of bash, we're going to use shell, sh. Okay, now we're doing a shell session inside this container. So let's look around. We have all these directories you're familiar with. We talked about this in the previous section. I hope you didn't miss that. So this is Alpine Linux. And in this image, we also have Node. So if you type node -- version, we can see the version of Node, which is 14.16.0. Now in this image, we don't have our application files. We only have Alpine Linux and Node. So in the next lesson, I'm going to show you how to copy application files into this image. Now that we have a base image, the next step is to copy the application files into the image. So for that, we have 2 instructions. One is copy, the other is add. They have the exact same syntax, but add has a couple additional features. We'll talk about that later in this lesson. So let's start with copy. With this, we can copy 1 or more files or directories from the current directory, meaning this directory over here, into the image. So we cannot copy anything outside of this directory. Here's the reason. When we execute the build command, look at the last argument. A period means the current directory. So when we execute this command, Docker client sends the content of this directory to Docker engine. This is called the build context. So Docker client sends the build context to Docker engine, and then Docker engine will start executing these commands one by one. So at that point, Docker engine does not have access to any files or directories outside of this directory, okay? So here we can copy 1 or more files. For example, we can copy package.json into /app into the image. Now, if this directory doesn't exist, Docker will automatically create it. We can also copy more than 1 file. So we can say readme.md. And by the way, remember, this is case sensitive because under the hood, we are using Linux. Now here we have a syntax error. Look, when using copy with more than 1 source file, the destination must be a directory and end with a /. So here we need to add a /. Okay. We can also use patterns. So let's say we want to copy all files that start with package and end with JSON. So whatever comes in between, we don't care. That's why we're using a wildcard. So in this directory, we have 2 files that match this pattern. We have package-lock.json and package.json. Package.json, as I told you before, includes the list of dependencies and their versions. But the actual versions that may be installed on this machine might be a little bit different from what we see here. So package.lock.json keeps track of the exact version of these dependencies installed on this machine, okay? Now, what if you want to copy everything in the current directory into the app directory? We use a period. So this is all about source files and directories. Now, let's talk about the destination. So here we're using an absolute path because our path starts with a /. We can also use a relative path if we set the working directory first. So using the work there instruction, we can set the working directory. Now, all the instructions that come after will be executed inside this working directory. And with this, we can replace this absolute path with a relative path. So we can use a period, meaning the current directory, okay? Now, one last thing about copy. What if you want to copy a file that has a space in it? So let's say we have a file called helloworld.txt. Look, we immediately get a syntax error. This is where we use the other form of the copy instruction. So copy has another form where we can pass an array of strings. So multiple strings. Each string represents an argument of the copy instruction. So here, we're going to wrap all these arguments inside brackets. Then we're going to wrap the first item, which is our source file, in double quotes. Then we add a comma and wrap the second argument in double quotes. It's not a form that you use that often, but I thought to cover it to make this lesson comprehensive. So let's simplify things. We're going to copy everything in our context directory, which is the current directory, into the current working directory of the image. Okay. Now, we also have add. It has the exact same syntax as copy, but add has two additional features. With add, we can add a file from a URL. So here we can type HTTP, some URL, and let's say some file.json. So if you have access to this file, we can add it to our image. The other feature is that if we pass a compressed file, add will automatically uncompress this into a directory. So you can use either of these instructions, but the best practice is to use copy because it's more straightforward. There's no magic around it. Use add only if you need one of these additional features. If you want to add a file from a URL, or if you want to uncompress a compressed file. So let's get rid of this. We're going to copy everything in the current directory into our image. So let's go ahead and rebuild our image. All right, now look at this line. Transferring context. So all the files and directories in our current directory are being sent to Docker Engine. All right, the image is built. So let's start the container with this image. Docker run interactive React app. We're going to run shell so we can look at the file system. Okay, look, we're inside the app directory because in our Docker file, we set this directory as the current working directory. Now let's run ls. So here you can see all the files and directories we have in our project, including node modules. So this is all about copying files. Now, what if you want to exclude some files or directories? We'll talk about that next. In the last lesson, you saw that when we build our application, Docker client takes everything in this directory, which is called the build context or the context directory. So Docker client takes everything here and sends it to Docker Engine or Docker daemon. Now for this simple application, which has absolutely no features, our build context was about 150 megabytes. But why is it so large? That's the result of the node modules directory. So if you look over here, you can see tons of directories and subdirectories, and this is a very simple project. As our application gets more complex and we use more third-party libraries, this node modules directory gets larger and larger. Now, there's a problem here. Later in the course, when we talk about deployment, you will see that our Docker client will talk to a Docker engine on a different machine. So that means whatever we have in the build context has to be transferred over the network. So if you have a large build context with a million files in it, all these files have to be sent to the Docker engine on the remote machine. We don't want that. We don't really need to transfer this node modules directory because all these dependencies are defined in package.json. So we can simply exclude this directory and copy everything else and then restore these dependencies on the target image. And this has two benefits. The first benefit is that our build context is smaller, so we transfer less data over the network. The second benefit is that our build is going to be faster, so we don't have to wait for all these files to be transferred to Docker Engine. Okay? Now, how do we exclude this directory? Very easy. You are probably familiar with this file, .gitignore. With this file, we can exclude some files and directories from Git. Now, we have the same concept in Docker. So we can create a file in the root of this project called .dockerignore, and everything is in lowercase. And here we can list the files and directories that should be excluded. So we can exclude node modules. Now, when we build a new image, Docker will no longer transfer this large, gigantic directory to Docker Engine. Let's take a look. So I'm going to run the build command one more time. Good. Okay. Look at our build context. It's only 10 kilobytes. So we reduce our build context from 150 megabytes to 10 kilobytes. That's a huge improvement. There is a problem though. If we start a new container and look at the file system of that container, we're not going to see the node modules directory because we excluded it, right? Let's verify it. So I'm going to run a new container from React App and then run shell inside that container. Now in the app directory, let's look at all the files and directories. Look, we only have two directories here, public and source. So node modules is not here. This is where we need to run npm install to install these dependencies. And that's what we will do next. All right, the next step is to install our project dependencies using npm. This is where we use the run command. With this command, we can execute any commands that we normally execute in a terminal session. So we can run npm install. We can also run any of the Linux or Windows commands. For example, let's say we want to install Python on this image as well. We can use apt or apt-get to install Python. Now, if we run this, we're going to get an error because Alpine Linux doesn't have apt package manager. It has another package manager called APK. So be aware of these differences depending on the type of Linux or Windows you're using, okay? So we don't need to do this in this lesson. Let's just install the dependencies of our project. So now back to our terminal, let's rebuild the image. All right, so now Docker Engine is running npm install to download and install these dependencies. This is going to take a few seconds, so I'll be right back. All right, our image is ready. So let's start a new container with this image and run shell. Good. Now let's look at our app directory. All right, and here we have the node modules directory. Beautiful. So we're done with this step. Next, I'm going to talk about setting environment variables. Sometimes we need to set environment variables. For example, let's say this front-end application needs to talk to a backend or an API. Quite often, we set the URL of the API using an environment variable. This is where we use the env instruction. So we can set API URL to, let's say, HTTP API myapp.com, whatever, doesn't really matter. We also have an older syntax without an equal sign that also works. I personally prefer to have an equal sign so we can clearly see the value of environment variables, but that's just my personal preference. Now, let's rebuild the image and inspect this environment variable in our container. So we're going to rebuild the image. All right, the image is built. So let's start a new container. Now, do you remember the command that we use for inspecting environment variables? We have a few options. One way is to use printenv to see all environment variables. So you can see API URL over here. Beautiful. We can also print the value of a particular environment variable. Another option is to use echo, but here we have to use a $sign to print API URL. Okay, so now whenever we start this container, this environment variable is automatically set for us. All right, let's take a quick break from our Docker file and start this application outside of Docker, the way we have always started it. So from the project directory, we run npm start. Now this starts a development server on port 3000. So if you go to localhost port 3000, we can access this application. Now in the future, when we run this application inside a Docker container, this port 3000, will be open on the container, not on the host. This is something important you need to understand. So on the same machine, we can have multiple containers running the same image. All these containers will be listening to port 3000, but the port 3000 on the host is not going to be automatically mapped to these containers. So later in the next section, I will show you how to map a port on the host to a port on these containers. But for now, we're going to go back to our Docker file and use the expose command to tell what port this container will be listening on. That is port 3000. So I just want to clarify something. The expose command doesn't automatically publish the port on the host. It's just a form of documentation to tell us this container will eventually listen on port 3000. So later, when we properly run this application inside a Docker container, we know that we should map a port on the host to port 3000 on the container. We'll do that in the next section. All right, now let's talk about users. So by default, Docker runs our application with the root user that has the highest privileges. So that can open up security holes in our system. So to run this application, we should create a regular user with limited privileges. But before doing that in the Docker file, let's open up a shell session on Alpine Linux and play with a few commands. Now, if you're a Windows user, I still want you to follow along. Even though the commands I'm going to show you are not going to be relevant, the approach I'm taking is absolutely relevant. So take this approach and implement it on top of Windows. You just have to use different commands, okay? So we're going to run Docker run in the interactive mode, Alpine. So here we have a shell session. Now, in this image, we don't have the user add command. Instead, we have add user, okay? So look at these options. There are two options we're going to use. One of them is -G for setting the primary group of the user, and the other is -S for creating a system user. We're going to use a system user because this user is not a real user. It's just for running an application, okay? Now, before using this command, we have to create a group so we can add this user to that group, okay? So to do that, we're going to use add group. We're going to give this group a name, let's say app, okay? Now we can run add user, -S for creating a system user, -G for setting the primary group, which is app, and finally we specify the name of the user. We're going to use the same name. This is a common best practice in Linux. So whenever we create a new user, we create a primary group for that user with the same name, okay? Now we have a new user. Let's verify that this user is in the right group. So we type groups, app. This shows the groups for the app user. Perfect. Now, we're going to combine these two commands into a single command. So let's create another group and a user. We type add group. We can say mosh or whatever. We use double ampersand to combine two commands. Add user, -S, -G, mosh, mosh. So we used a single command to perform two tasks, okay? Now let's verify the groups for mosh. Perfect. So this is the command that we're going to run in our Docker file. So let's copy this. Now back to our Docker file. We're going to run a command. How do we do this? We use the run instruction. Then we paste our command. And instead of mosh, we're going to use app. So we're going to create a group and a user called app, okay? Once we do that, then we can set the user using the user command. So all the following commands will be executed using this user. Let's save the changes and rebuild our image. So here's the build command. Let's go ahead. All right, our image is ready. Now look at the fifth step. That is our run command for creating a new group and a new user. Now you might have noticed that building this image took probably a long time. That was because of this step, installing the dependencies. Now you might argue that earlier we excluded the node modules directory so our builds would be faster, but our builds are still slow because every time we build this image, all these dependencies have to be installed. Don't worry about that. We're going to optimize this later in this section. Now let's start a new container and make sure the current user is the app user, not the root user, okay? So Docker run. In the interactive mode, we're going to run React app and start a shell session. Good. Now, what command should we use to print the current user's name? Do you remember? I told you at the beginning of the Linux section, that is who am I? So the app user, beautiful. Now let's look at something interesting. I'm going to get a long listing. These are the files in our application. Now all these files, as you can see, are owned by the root user. And in this column, you can see the permissions of the root user. So the root user can write to any of these files or directories, but the current user running the session is the app user. So this user falls into the others group. That means the app user is not able to write to any of these files. In contrast, if we executed this application with the root user, a hacker could potentially rewrite something in our application. So we're done with users. Next, we're going to talk about defining entry points. All right, our Docker file is almost ready. Now, how do we start our application? Well, earlier you saw that here in the project directory, we can start the application by running npm start. So this is the command that we should execute when starting a container. So let's start a container, docker run. Now we're not going to use the interactive mode because we don't want to interact with this container. We're not going to run a shell session. We just want to start the application. So we type the image name. Now let's see if we execute this command up to this point. Our container started and then stopped because we didn't specify a command or a program to execute. So this is where we're going to type npm start. Take a look. All right, we got a permission error. Look over here, permission denied. Can you tell why we're getting this error? Think about it for a few seconds, and I'll give you a hint. Look at the Docker file. Here's the answer. In our Docker file, we set the user at the end. So we executed all these previous instructions as the root user, but then we switched to a regular user with limited privileges. So we should move these two lines on the top. So first, we set the user, then we create the working directory, copy files, and so on. Now we have to rebuild our image and start a new container. So back in the terminal, let's stop this process by pressing Ctrl and C. Good. Now, docker build -t React app, period. All right, our image is ready. So let's start a new container. All right, our web server started on port 3000. But as I told you before, this is port 3000 of the container, not localhost. So if we go to this address, we're not going to be able to access the application. In the next section, I will show you how to map a port from the host to a port on the container. Okay. Now, let's start this process. Let's bring up the run command. Now, here's a problem. We don't want to have to specify this command every time we start a container. This is where we use the command instruction. So back to our Docker file. At the end, using the command instruction, we can supply a default command to be executed. So npm start. Now, back to the terminal. Once we rebuild the image, then we can start a container by simply running docker run React app. We don't have to specify the command here. Great. Just remember, because the command instruction is for supplying the default command, it doesn't make sense to have multiple command instructions in a Docker file. If you have multiple command instructions, only the last one will take effect. Okay? Be aware of that. Now, you might be wondering, what is the difference between the command instruction and run? Because with both these, we can execute commands. Here's the difference. The run instruction is a build time instruction. So this is executed at the time of building the image. So when building the image, we're installing npm dependencies, and these dependencies are stored in the image. In contrast, the command instruction is a runtime instruction. So it's executed when starting a container. Okay. Now, this command instruction has two forms. What you see here is called the shell form. We also have another form called execute form, which takes an array of strings. So npm and start. What is the difference? Well, if we use this syntax, Docker will execute this command inside a separate shell. That is why it's called the shell form. Now, on Linux, that shell is /bin/shell, the original shell program. On Windows, it's CMD or command prompt. Now, the common best practice is to use the execute form, because with this, we can execute this command directly, and there's no need to spin up another shell process. Also, this makes it easier and faster to clean up resources when you stop containers. So always use the execute form. So let's get rid of these. So here's our command instruction. Now we also have another instruction called entry point, which is very similar to command. So it has two forms, the shell form or the execute form. So it takes an array of strings. Now, what is the difference? Well, we can always overwrite the default command when starting a container. So back to the terminal, when we run this container, we can supply another command. So we can say echo hello, and this will overwrite this command over here. So for the same reason, here we can run a shell session, and of course, we want to use the interactive mode. Now, in contrast, we cannot easily overwrite the entry point when running a container. If you want to do that, we have to use the entry point option. Now, a lot of people forget to use this, That's why it's a little bit harder to overwrite the entry point. So in practical terms, we often want to use entry point when we know for sure that this is the command or this is the program that should be executed whenever we start a container. There is no exception. In contrast, with the command instruction, we have a bit more flexibility. We can always overwrite this. So we want to use this instruction for executing ad hoc commands in a container. Now, which instruction you use is a matter of personal preference. With both these instructions, we can supply a default command. Some people prefer the command instruction, other people prefer the entry point. I personally prefer the former, so I'm going to get rid of this. Good. So our Docker file is in a good shape, but if you have noticed, our builds are slow. We'll talk about optimizing them next. You've probably noticed that our builds are fairly slow. Every time we make a small change, we have to rebuild and wait almost half a minute. So let's see how we can optimize these builds. The first thing you need to understand here is the concept of layers in Docker. An image is essentially a collection of layers. You can think of a layer as a small file system that only includes modified files. So when Docker tries to build an image for us, it executes each of these instructions and creates a new layer. That layer only includes the files that were modified as a result of that instruction. So for our first instruction, Docker is going to take the node image and put it in a layer. Now, more accurately, the node image itself is several layers. But let's not worry about that for now. Let's just imagine we have a single layer, and this layer includes all the Linux and node files. Then Docker is going to execute the second instruction to add a group and a user. Once again, it's going to create a new layer because as you saw in the previous section, when we add a user or a group, something is written to the file system. So a couple of files are modified. So this layer will only include the modified files. Okay. Similarly, Docker will execute all these other instructions and create several layers. Let's have a quick look at these layers. So here in the terminal, we type Docker history and the name of our image, React app. All right, let me move this window around so you can see things clearly. Okay, we're only going to look at these two columns, created by and size. In this column, you can see the instruction that created a new layer. And in the size column, you can see the size of that layer. Now we have to read this list from bottom to top. So look over here. First, we have this group of layers that come from Node and Linux. So earlier I told you that when we use the from instruction, that instruction is going to bring in several layers that belong to Linux and Node. And then we're going to build on top of those layers. Okay. Now look at our run instruction for adding a new user. That's the command that we typed earlier, right? Now look at the size of this layer. It's 4 kilobytes because only a couple of files are modified as a result of this command. Now look at how this instruction is executed. It's executed inside /bin/shell because we use this instruction in the shell form. In contrast, if we use the execute form, this command would be executed directly, okay? Next, we set the current user. The size of this layer is 0. No files are changed. Then we set the working directory. Then we copy all the application files. And over here, you can see the size of this layer is 1.6 megabytes. Then we run npm install. And once all these dependencies are installed, they are stored in this layer. And the size of this layer is 178 megabytes. So an image is essentially a collection of these layers. So you understand what layers are. Now, Docker has an optimization mechanism built into it. So next time we ask Docker to build this image, it's going to look at the first instruction and see if the instruction is changed or not. If it's not changed, it's not going to rebuild this layer. It's going to reuse it from its cache. That's the optimization I was talking about. Then Docker is going to look at the second instruction. Once again, nothing is changed here, so Docker is going to reuse this layer from its cache. In contrast, if we made a tiny change here, let's say if we changed app to app2, then Docker had to rebuild this layer, okay? Now, look at this line. Copy all these files. This is a special instruction because with this instruction, Docker cannot tell if anything is changed or not. So it has to look at the content of files as well. And that means if we make a tiny change in our application, if we write one extra line of code, Docker cannot reuse this layer from its cache. It has to rebuild it. And this is where the problem happens. Once the layer is rebuilt, all the following layers have to be rebuilt as well. So Docker cannot reuse this layer from its cache. It has to install all npm dependencies. And this is exactly where we have a bottleneck. we have to wait half a minute for all these dependencies to be installed. It doesn't make sense. So to optimize our build, we have to separate the installation of third-party dependencies from copying our application files. How do we do that? Very easy. Instead of copying all the files in one go, first we want to copy the files needed for installing third-party dependencies. Do you know which files I'm talking about? These two files, package-lock.json and package.json. These are the only files that we need for running npm install, okay? So we're going to copy package star.json. Then we run npm install. And finally, we copy all the application files. Now, with this new setup, if we haven't changed any of our application dependencies, Docker is going to reuse this layer from its cache because package.json is not modified, right? Similarly, Docker is not going to reinstall all npm dependencies because this instruction is not changed. If we change this to npm update, then yes, Docker had to rebuild this layer, okay? But nothing has changed here, so Docker can reuse its cache. Then we're copying our application files, and of course, this layer should always be rebuilt, and that's totally fine. So let's run a quick test. Back to the terminal, let's rebuild this image. All right, now look over here. On this line, you can see cached because Docker is reusing the layer cache for this instruction. The same is true for setting the working directory. Now, this is the first time I'm building this Docker file. That's why this is a new layer that we have. This layer has to be built. And of course, dependencies have to be installed as well. So let's wait until this is done. All right, the image is built. Now let's go modify our application code and do another build. So I'm going to go to this file, readme.amd, and add a plus here. Very simple. Now, let's do another build. All right, our build was super fast because we didn't have to wait for the installation of third-party dependencies. Look at this line. Once again, we are using layer caching. So here's what you need to take away from this lesson. To optimize your builds, you should organize your Docker files such that the instructions that don't change frequently should be on the top, and the instructions or files that change frequently should be down the bottom. Let's talk about removing images. So first we run docker images. Now in this list, we have a bunch of images that have no name and no tag. These are what we call dangling images, meaning loose images. These are essentially layers that have no relationship with a tagged image. So as we were changing our Docker file and rebuilding our image, Docker was creating these layers, and at some point, these layers lost their relationship with our React app image. So as you work with Docker, you see these dangling images popping up all the time. To get rid of them, we have to use the prune command. So we type docker image prune. It's asking for confirmation. Yes. All right. Nothing was deleted in this case because we still have containers running an older React app image. Let's verify it. So we run docker ps. Currently, we have no running containers, but we probably have a bunch of containers in the stopped state. So we run docker ps-a, that is short for all. So look, we have tons of containers that are currently stopped. So we can get rid of these containers as well. How? Very easy. Docker container prune. So it's asking if you want to remove all stopped containers. Yes. Good. So all these stopped containers are deleted, and this freed up on this machine 60 megabytes of space. Now let's run docker image prune one more time. Yes, great. So all these dangling images are removed. Now, if we run docker images, we only see the proper images we have created or pulled from Docker Hub. Great. Now, how do we remove one of these images? We run docker image. So all image management operations start with docker image. If you simply press enter here, you can see all these subcommands. So we can build an image. This is equivalent to running docker build. We can also see the history of an image. We can load an image. We can prune images and so on. Now in this list, we also have remove for removing one or more images. So let's bring up the list of images one more time, because here we need the name or the ID of an image. So we can run docker image remove. We can either reference an image by its name. For example, we can remove React app, or we can reference using its image ID, df3. And if you want to remove multiple images, we type them all here, separated by a space. Now in this demo, I want to delete hello Docker image. Okay, let's verify it's gone. Docker images, good. All right, let's talk about tags. If you have noticed, whenever we build an image or pull it from Docker Hub, by default, Docker uses the latest tag. Now, this latest tag is just a label. There is nothing special about it. So it doesn't necessarily mean this is the latest version of your image. If you don't tag your images properly, latest can point to an older image. I will show you that in a second. Also, keep in mind that latest is totally fine for development, but you shouldn't use it in production. You don't want to put an image with the latest tag in your production or staging server, because if something goes wrong, you cannot easily troubleshoot issues because you don't know what version you're really running in production. If you want to do a rollback or an upgrade, how can you tell what version you're running in production if it's always latest? So you should always use explicit tags to identify what version you're running in each environment, in your test environment, staging, and production. For development, latest is totally fine. Now, in this lesson, I'm going to show you how to tag your images properly. But before we get started, I want to do a clean build. So we start on a clean canvas. So Docker build -t React app period. Good. So let's look at our images. We have 3 images and all of them have the latest tag. Now, how can we tag an image? Well, there are 2 ways. One way is to tag an image while building it. So we type Docker build -t for tag. So far, we have just typed the image name, but we can type a colon followed by a tag. Now, what tag should we use? Well, this is where different teams have different preferences. Some teams like code names. Let's say you have a version called Buster, and everyone in your team knows what Buster version is all about. Then you can use it as a tag. Other teams prefer semantic versioning, like 3.1.5. This approach is common amongst teams that don't release that often. Now, teams that release frequently prefer build numbers. Let's say build 76 or 77. Now, quite often, this is done automatically by a continuous integration and deployment tool. So if you use a continuous integration or deployment tool in your organization, you can configure your tool to check out the latest code from your repository, build an image, and automatically tag it with the current build number. Now, that's outside the scope of this course. So let's go ahead and give this image a tag like version 1 and build it. All right, our build was blazing fast. Let's look at the images one more time. All right, here we have an interesting situation. This React app image that we have has 2 tags, 1 and latest. So it's the same image with multiple tags. How do I know? Look at the image ID. Both these images have the same identifier. So an image can have multiple tags. Now, what if we made a mistake and want to remove this tag? Well, we use the remove command. So Docker image remove, and here we type the image name followed by the tag. Okay, the tag is gone. So let's look at the images. Perfect. We only have the latest tag. So one way to tag an image is while building it. But what if you want to tag an image after? We use the tag command. So Docker images tag. First, we identify our source image. We can use the full image name and its tag, or we can use an image ID, whatever you prefer. So we're going to get this image and apply a new tag to it. React app version 1. I made a mistake because I spelled images as plural. So that should be Docker image tag React app latest. We're going to give it a new tag. Good. Now let's verify that everything is in the right shape. Perfect. Now, earlier I told you that the latest tag can get out of order. Let's see that in action. So I'm going to go back to our project and make a tiny change. In this README file, I'm going to add a couple more pluses simulating a change in the application's code. Now we're going to build a new image. So let's say Docker build -t React app. Let's say this is version 2. Okay, great. Now let's look at the images. So we have 2 versions of this image, version 2 and version 1. Now look at the latest tag. It's pointing to the first version. Because both these tags are pointing to the same image, which is older. I built this image at the beginning of this lesson. So here's what you need to take away. The latest tag doesn't necessarily reference the latest image. You have to explicitly apply it to the latest image. So how do we do that? Pause the video and do this on your own. Here's how we do it. Docker image tag. We're going to identify our image. This time I'm going to use the image ID. So we can type B06. We're going to give this image a new tag, React app latest. Okay. Now let's look at the images again. Good. So now the latest tag is pointing to version 2 of our image. Great. Next, we're going to talk about sharing images. Let's see how we can share our images with others. So head over to hub.docker.com and create a new account. It's absolutely free and it's going to take only a few seconds. Now, let me log in with my account. Good. So on this page, we can create a new repository. And this is similar to creating a GitHub repository. So we can have a repository, and in this repository, we can have multiple images with different tags. So let's create a new one. We're going to give it a name. I'm going to use the same name that I used for our image. Now we can give it a description. We can make it public or private. If you have a free account, you only get one private repository, but you can always upgrade to get additional private repositories. Now, optionally, we can connect our account to our GitHub account. So every time we do a push, Docker Hub automatically pulls the latest code and builds a new image. Now, I'm not going to do that in this lesson, so let's go ahead and create. Good. So here we have a repository, and this is the name of our repository. So our username / our image name. Now, to push our image to this repository, we have to give it this tag, code-with-mosh, or whatever your username is, /React app. So back to the terminal, let's look at our images. Let's say I want to publish the latest version of this image. So Docker image tag. We're going to tag this image. I'm going to use the image ID, so B06. I'm going to give it a new tag, code-with-mosh /React app. Now, if you don't specify a tag, Docker will automatically use latest. We don't want to do that. We want to use an explicit tag. Okay. Now, let's look at our images one more time. So now, this image with this ID has 3 tags. Here's the first tag, tag 2. We also have the latest tag, but we also have code-with-mosh /React app with tag 2. All these tags are pointing to the same image on my machine. Okay, so now we're ready to push this image. First, we have to log in. So Docker login. We use our credentials. Good, I'm logged in. Now we type Docker push, and here we specify our image. So code-with-mosh /React app version 2. All right, now Docker is pushing each of the layers in our image. So the first time we push this image, this is going to take a little while because one of our layers, the layer that includes all NPM dependencies, is fairly large. So once we push this image, our future pushes will be faster, assuming that we have not changed our application dependencies. So our image is pushed. Now let's refresh this page. So in this repository, we have one tag that is tag 2, which is built for Linux. Great. Now back to our project, let's make a small change to this README file and do another push. Back to the terminal. First, we need to build this image. So build -t, React app, let's say version 3. That was super fast. Now, let's look at the images. This is our version 3. Now we want to give this image an extra tag that starts with code-with-mosh, or our username. So Docker image tag. I'm going to tag React app version 3 with code-with-mosh /React app version 3. Good. So let's say Docker push code-with-mosh React app version 3. All right, now look, some of these layers already exist. So this push is a lot faster than the previous push. Done. Now back on Docker Hub, let's refresh. Now in this repository, we have 2 tags. Beautiful. All right, now that our image is on Docker Hub, we can put it on any machine that runs Docker, just like pulling any other images from Docker Hub. All right, the last thing we're going to talk about in this section is saving and loading images. Let's say you have an image on this machine and you want to put it on another machine, but without going through Docker Hub. In this case, you can save that image as a compressed file and load it on the other machine. So let's run docker image save. Now for any of these commands, if you want to learn more about them, you can always add --help at the end. So here's the syntax. Docker image save. You have to use one of these options, like O, which is the short form, or output, which is the long form. Here we specify the file to write to, and then we identify the image. So I'm going to say docker image save -o. So I'm going to save this to a file in the current directory called reactapp.tar. A tar file on Linux is like a zip file on Windows. It's a compressed file. And then we specify our image. Let's say React App version 3. Now, this is going to take a while, so I'll be right back. All right, our image is saved. So here we have a tar file. We can double click it to uncompress it. Now, let's see what we have here. Each of these folders represents a layer. Now, if you're adventurous, we can go inside each of these layers and see what is really inside that layer. So each layer contains a JSON file and a tar file, which contains all the files in that layer. So let's open this up. Here we have an app folder. So that means this is the layer that represents our application code. You can go look at other layers. You will find a layer for Linux. You'll find a layer for Node and so on. So we have the save command for saving an image into a file. We also have the load command. Let's look at that real quick. So we type docker image load and then use one of those options. We can use I or input to specify the file name. And optionally, we can use the quiet option to suppress the load output. So to demonstrate this, first I'm going to delete the image from this machine and then load it using our image file. So docker image remove React App version 3. It's gone. Let's look at the images. Good. Now, technically, we still have this image because there is another tag pointing to this image. So let's remove that tag as well. Docker image remove. In fact, you know what? I'm going to use the image ID. That's easier. Good. Now let's look at the images one more time. All right, perfect. That image is gone from this machine. Now I'm going to load it using our image file. So we type docker image load -i reactapp.tar. All right, we can see this image is loaded. So let's verify it. And here we have React App with tag 3. And this is the same image ID that we had earlier. So that brings us to the end of this section. I know this was a long section. We had a lot of ground to cover. But now that you have a solid understanding of images and how to work with them, everything is going to go smoothly from the following sections. So I will see you in the next section. Welcome back to another section of the Ultimate Docker course. In this section, we're going to explore containers in more detail. We'll talk about starting and stopping containers, publishing ports, viewing container logs, executing commands in running containers, removing containers, persisting data using volumes, and sharing source code with containers so we don't have to rebuild our image every time we make a change in our code. This is a short and sweet section, so let's jump in and get started. All right, we briefly talked about container commands throughout the course, so you're already familiar with many of them. In this section, we're going to review them one more time, but I'm also going to give you some extra tips along the way. For starters, let's look at our images. So I've cleaned up some of the images that I created in the previous section. Now we only have React App with the latest tag. We also have Ubuntu and Alpine, which we're not going to use in this section. Now, hopefully you completed the previous section, but if you didn't, I highly encourage you to download the zip file app attached to this lesson. In this zip file, you can find our React application as well as the Docker file that we created in the previous section. Use that Docker file to build an image, and now we are on the same page. Okay. Now, question for you. How can we see the running containers? Using Docker what? Docker PS, short for processes, because a container is just a process, but it's a special kind of process because it has its own file system, which is provided by the image. Okay, currently there are no running containers here. So I want to run a new container using the React app image. This is going to start a development web server. So I'll be right back. Okay, our web server is ready. Now there's a problem. I cannot type any additional commands on the terminal window. If I press Ctrl and C to get out of this, our container stops. Let's verify that. So Docker PS, look, no container is running. So let me show you a cool technique. Let's bring up the run command one more time. Now this time we're going to use an option -d that is short for detached. With this, we can run this container in the detached mode, which means in the background. So look, that's it. Now the terminal window is free and we can do whatever we want. Of course, the container is going to take a few seconds to start because that's the time we need for the web server to start. Okay, so that's one option. Now let's look at the running processes. So here we have one container. Here's my container ID. Now, if you look on the far right column, which is not visible in my recording window, and I don't want to resize this window because the text is going to get small. In the last column, you can see the names column. So Docker automatically associates each container with a random name. So in the future, when we want to reference a container, we can either use its ID or its name. But we can also give our container a name when starting them. So let's start another container in detached mode. This time we're going to use --name to give it a name. I'm going to call this blue-sky. It's easier to work with than a randomly generated name by Docker. And we're going to use the React app image. Good. So let's look at the running containers. Now we have two containers and one of them is called blue sky. So now we have two containers running in the background, but there's a problem. We don't know what is going on inside these containers. What if something goes wrong? What if our server generates an error? That's where we need to use the log command. But first, let's bring up our running containers. So now we're going to look at the logs for this container. We type docker logs and then the container ID. Of course, on your machine, the container ID is different. So whatever it is, just type the first few letters. Okay, so here we can see the output of our web server. This is exactly the same output that we saw when we started this container in the foreground. Now, this logs command has some additional options. So as I told you before, whenever you want to play with the Docker command, always use --help to learn about various options. So one of the options here that is useful is -f or follow. This is useful if your container is continuously producing output. So instead of running Docker logs, some container ID multiple times, you can just use -f to follow the log. Then whatever is written to the log, you can see it in real time on the terminal. Of course, you have to press Ctrl and C to get out of that. Let's look at the other options. Another option is -n or tail. And with this, we can specify the number of lines to show. This is useful if we have a really long log. So Docker logs, what was that container ID? 655. I'm going to use -n5 to look at the last 5 lines. That's it. Pretty useful. Now, what if you want to see timestamps? We can use -t. So -t. And now we see the timestamp in front of each message. So if you encounter any issues when running your applications inside Docker, the first thing I want you to look at is the logs. Next, we're going to talk about publishing ports. So currently we have 2 containers running our React application. But if we go to localhost port 3000, we cannot access this application. Can you explain why? Because as I told you earlier, port 3000 is published on the container, not on the host. So on the same machine, we have multiple containers. Each of these containers is listening on port 3000, but the host itself is not listening on this port. So this port is currently closed. There is no way to send traffic into localhost at this port. This is where we need to publish a port. So first of all, let's look at our running containers. Now here we have a column called ports. Let me resize the window. It's going to look a little bit ugly, but bear with me. So we have wrapping here. Here's the ports column. In this column, you can see the ports and their mapping. As you can see, both these containers are listening to port 3000. Now I'm going to start a new container and publish a port at the same time. So just like before, we run docker run -d for detached. Here we're going to use another option called p, that is for port. We're going to publish a port on the host, let's say port 3000 to port 3000 of the container. And of course, these numbers don't have to be the same. So I can publish port 80 of the host to port 3000 of this container. Now I can give this container a name so we can identify it. I'm going to call this C1. Now, what image? React app. Good. So this is going to take a few seconds until our web server is ready. Now, if we go to localhost port 80, we can see our React application. Beautiful. Now, let's look at the running containers one more time. Now look at the port mapping for our C1 container. You can see port 80 of the host is mapped to port 3000 of the container. We do not have this notation for other containers. So you'll learn that when we start a container, it executes the default command that we specified in our Docker file. Now, what if you want to execute a command in a running container later on? Let's say we want to troubleshoot something and we want to look at the file system of that container. Let me show you how to do that. So we have docker exec or execute, and with this we can execute a command in a running container. Now some people say, what is the difference between docker exec and docker run? With docker run, we start a new container and run a command, whereas with docker exec, we execute a command in a running container. Okay. Now for this, I'm going to use my C1 container. This is the benefit of using friendly names. Now, what do we want to execute here? We can type any commands, any operating system commands. So this can be Linux commands or Windows commands. Let's run ls here. Now we can see the content of our app directory. But why the app directory? Can you explain why? Here's the answer. Because earlier in our Docker file, we set the working directory to the app directory. So when we run ls, we see the content of this directory, okay? Now, using the same command, we can open up a shell session. So we can say docker exec. We want to do this in the interactive mode so we can interact with it. Our container is C1 and the shell we want to run is sh. Good. So now we have a shell session inside this container. We can run ls. We can run print working directory. We can do anything we want. Now, when we're done, we type exit, and this doesn't impact the state of our container. Our container is still running. Let's verify it. Docker ps. So our C1 container is the first item you see here. So using the exec command, we can execute any commands in a running container. Earlier in the course, I told you that a container is like a lightweight virtual machine. So it can be stopped and then restarted. Let's see this in action. So I'm going to stop our C1 container. Good. Now let's verify that it's not running. It's not running anymore. Great. So now if you go back to our browser and refresh this page, look, our application is not available because that container that was serving this application is no longer running. It stopped. So we need to bring it back up. And that is very easy. We just type docker start C1. Now, what is the difference between docker start and docker run? With docker run, we start a new container, whereas with docker start, we start a stopped container. Okay? Next, we're going to talk about removing containers. There are two ways to remove a container. We can type docker container remove and then specify the name, or we can use the shortcut docker remove. I prefer this. So let's go with that. We get an error saying you cannot remove a running container. So here we have two options. One option is to stop the container and then remove it. The other option is to use the force option. So if you want to force the removal, we bring up the last command and type -f here. Okay, that container is gone. So let's look at the running containers. It's definitely not here. Now, how can we see the stop containers? Do you remember? Docker ps -all. Now, even though we have a bunch of containers here, that container C1 is not in this list. Now, let me show you a cool trick. Let's say you have so many containers here and you only want to look at C1. Here we can use piping. We talked about piping Linux commands earlier in the course. So we can say docker ps -a. Here we type a pipe and then use grep to filter by C1. Of course, this only works on Linux. So let's go with that. Look, we don't have a stub container called C1. Now here we also have the prune command. So docker container prune. And with this, we can get rid of all the stub containers in one go. Take a look. Good. So let's look at the running containers one more time. 2 containers here and all containers, 2 containers. Great. Next, we're going to talk about persisting data using volumes. Earlier in the course, I told you that each container has its own file system that is invisible to other containers. So let's do a quick experiment together. First, we look at the running containers. So on this machine, I'm running 2 containers. I want you to run 2 containers as well. So if you're not, start 2 containers from the React app image. Then I want you to start a shell session on the first container and write something to a file in the application directory. Then start a new shell session on the second container and see if that file is there or not. So pause the video and work on this for a minute. All right, here's my solution. We're going to run docker exec in the interactive mode. The container ID is 655, and we're going to run shell. Now here in the app directory, I'm going to echo data to data.txt. Now I'm going to terminate this session and start a new shell session on the second container. So 6EB. Good. Now I'm going to list all the files and I want to filter using grep to find all files that have data in their name. Nothing. So data is not here because each container has its own file system that is invisible to other containers. And that means if we delete this container, its file system will also go with it and we'll lose our data. So we should never store our data in a container's file system. That's what volumes are for. We'll talk about them next. Let's talk about volumes. A volume is a storage outside of containers. It can be a directory on the host or somewhere in the cloud. So let's see how we can work with volumes. We have this command, docker volume, that has a bunch of subcommands. So we can create volumes, we can inspect them, we can list them, we can also prune and remove them. So let's create a new volume called app data. And of course, we can call it anything. It doesn't really matter. Now let's inspect this volume. So docker volume inspect app data. Now here we have a bunch of properties. We can see when this volume was created. We can see the driver, which is local by default. That means this is a directory on the host. We also have drivers for creating volumes in the cloud. So if you use a cloud platform, you need to do your own research and find a driver for creating a volume in that cloud platform. Okay. Now look at mount point. This is where that directory is created on the host. So this is a Linux path. If you're on Windows, you would probably see something like C drive / program files, whatever. Now a note for my Mac users. Earlier in the course, I told you that Docker on Mac runs inside a lightweight Linux virtual machine. So this path that you see here is a path inside that virtual machine. It doesn't exist on your Mac. So if you try to go to this directory, you're not going to find anything. Okay. So now we have a volume. Let's see how we can start a container and give it this volume for persisting data. So docker run, we're going to run it in detached mode. I'm going to map, let's say port 4000 of the host to port 3000 of the container. Now we're going to use a new option, -v for volume. We're going to map app data to a directory in the file system of the container. So here we type a colon followed by an absolute path in the file system of the container. So we can go to /app/data. Now we don't have to explicitly create this volume before running this command. So if I type a new volume here, Docker will automatically create it. The same is true for this directory. Currently, we don't have a data directory inside our app directory, so Docker will automatically create this. But there's a problem with this. We'll talk about it in a second. So we give it a volume and then the image, React app. Good. So here's our container ID. Let's start a shell session. So Docker exec interactive 716 shell. Good. Now let's go to the data directory and write something to a file. So data to data.txt. We get a permission error. Can you explain why this is happening? I want you to pause the video and think about it for a few seconds. Here's the reason. Let's go out of this directory and get a long listing. So here's our data directory. Now look at the owner of this directory. It's the root user. And over here, as you can see, the owner is the only user that has write permission. So the app user, which is the user that runs our app, belongs to the others group. And in this group, we don't have a write permission. The reason we're facing this issue is because we let Docker automatically create this directory for us. So to prevent this from happening, we have to go to our Docker file. So back to our Docker file. After we create the app directory, we're going to run make dir data. We're going to create this directory using the app user that we set earlier in this file. With this directory will be owned by this user and it will automatically have the write permission. But now we have to rebuild our image because we have modified our Docker file. So let's get out of this. So Docker build -t React app period. Okay, our build was super fast, great. So let's start a new container. Docker run -t. This time I'm going to use a different port mapping. Let's say port 5000 of the host to 3000 of the container. And for volume, we're going to map app data to /app/data. But this time, the data directory already exists inside the file system of this container, and the app user owns this directory. Okay. Now we give it our image, which is React app. Good. Now let's run a shell session inside this container. So Docker exec interactive 007 shell. Now let's go to the data directory and write something over here. Perfect. Now here's the beauty of volumes. If I delete this container, this file will still exist because this directory is stored outside of this container. It's actually a directory on the host. Let's see that in action. So I'm going to exit and remove this container. So remove -force. You have to force it because this container is still running. 007. That's gone. Now let's start a new container with the same volume mapping. So this is a brand new container. Now we're going to run a shell session here. So Docker exec interactive e1c shell. Let's go to the data directory and list. Look, our data file is here. Beautiful. So volumes are the right way to persist data in Dockerized applications because they have different life cycles from containers. If we delete a container, the associated volume is not deleted. It still exists. Also, we can share a volume amongst multiple containers. Sometimes we need to copy files between the host and a container. For example, let's say we have this log file in our container and we want to bring it to the host and analyze it. So let's look at the running containers. All right, I'm going to go to this first container and create a log file in the application directory. Then I'm going to copy that file from the container to the host. So let's run Docker exec interactive shell. Now here in the app directory, I'm going to echo hello to log.txt. So we have this log file inside the app directory, inside the container, and we want to copy it to the host. Let me show you how to do this. First, let's get out of here. Now Docker has a copy command for this. Here we need to specify a source and a destination. In this case, our source is the container. Now here we add a colon and then type the full path to a file or directory. So we're going to go to our app directory and copy log.txt to where? We use a period to reference the current directory in the host, which is our project directory. Okay, now let's list the files. So here's our log file. Beautiful. Now we can also copy a file from the host to a container. So let's create a secret file here and copy it to the container. So echo hello to secret.txt. And of course, this only works on Linux to the best of my knowledge. If you're on Windows, you can just create a file using your favorite text editor, okay? Now we have a file in our project directory in the host, and this file is not part of our version control system. It's not part of our Git repository. So we want to manually copy this file into the container. So I'm going to copy the container name one more time. So one more time, docker copy. Now this time the source is secret.txt, and the destination is the container followed by a colon and the path /app. Done. Now let's run a shell session and list all the files. So here's our secret file inside the container's file system. So we have this React application available at localhost port 5000. Now let's see how we can publish our application changes. So back to VS Code, we're going to go to the public directory and open index.html. Here I'm going to update the title of this app to Dockerized React App. This title is what we see in the browser window. So let's save the changes. Now back in the browser, if we refresh, we don't see anything. We still see the old title. So what should we do here? Well, for production machines, we should always build a new image, tag it properly, and then deploy it. We'll talk about that later when we get to the deployment section. But what about development machines? We don't want to rebuild the image every time we make a tiny change in our code. That's just too time consuming. Now you might say, what about copying? Well, that's a pain in the butt as well. We don't want to manually copy files from our development machine into a container every time we change our code. So let me show you a cool trick. We can create a mapping or a binding between a directory on the host and a directory inside the container. So this way, any changes we make to any files in this directory are immediately visible inside the container. So back to the terminal, we're going to start a new container. Docker run -d. This time I'm going to use a different port so we can distinguish it. We're going to map this port to port 3000. Now earlier we used a volume mapping. So we mapped the app data volume to /app/data directory inside the container. Now using the same syntax, we can map a directory on the host to a directory inside the container. So instead of using a named volume, which is a directory that Docker manages, we're going to use the current directory, the directory that holds our application. So we don't want to type the full path here. This is where we use the pwd command, print working directory. Now, if we execute this command as is, Docker thinks this is a named volume. We don't want that. We want a full path. So we're going to wrap this with a $sign and put it in parentheses. Now, when we execute this command, this part of the command will be evaluated first, and the result will be a full path to the current working directory. Then we're going to map this to not the data directory. We're going to map it to the app directory inside the container. Okay. Now, what about a named volume? Well, we can still add another option and use a named volume here if we want to, but this React application doesn't really store anything on the disk. It doesn't have a database. It's just a basic front-end application. So we don't need a named volume here. Now, let's add the image. Good. So here's the container ID. Let's look at the logs. This time I'm going to use the follow option so we can see the changes as they come up. Okay. We're waiting for the web server to start, so I'll be right back. All right, our web server is ready. So let's go to localhost port 5001. All right. We can certainly see the updated title. Now, let's make one more change to the application's code. So I'm going to add an exclamation mark at the end. Save the changes. Now, back in the browser, I didn't even have to refresh. Look, we've got the exclamation mark here. Because in React, we have this feature called hot reloading. So whenever we change any of our files, our application gets automatically reloaded in the browser. Okay. So to share our source code with a container, once again, we use the volume option to map the project directory to a directory in the container's file system. Now you might say, but Mosh, running applications with Docker is a pain in the ass. We have to remember all these options and type them every time we want to run our application. No, you don't. In the next section, we're going to talk about Docker Compose, and you will see how easy it is to bring up an application with multiple components. I had to cover all these commands and options, so when we get to the next section, you know exactly how Docker Compose works under the hood. So, I will see you in the next section. Welcome back to another section of the Ultimate Docker course. In this section, we're going to talk about running multi-container applications. So I'm going to give you a real-world application with 3 building blocks: a front-end built with React, a back-end built with Node, and a MongoDB database. Once again, you don't need to be familiar or use any of these tools. Our focus here is on Docker and not on development tools. I think this is the most exciting part of this course, where you can see everything coming together. We'll talk about Docker Compose for building and running multi-container applications. We'll also talk about Docker networking, database migration, and running automated tests. So let's jump in and get started. In this section, we're going to use a tool called Docker Compose, which is built on top of Docker Engine. It makes it incredibly easy to start applications with multiple containers. So Google Docker Compose install. You will find this page, docs.docker.com/compose/install. On this page, you can see the installation instructions. Now, at the time of recording this, Docker Compose is shipped with Docker Desktop for Mac and Windows. So if you're on Mac or Windows, you don't have to do anything extra. You already have Docker Compose. To verify it, just go to the terminal window and type Docker Compose --version. So I'm running Docker Compose version 1.28.5. Make sure your version is the same or newer. Now, if you're using an older version, again, Google upgrade Docker Compose. Or you might just install the latest version of Docker. Now, back to this page. If you're using Windows Server or Linux, there are specific instructions you have to follow to install Docker Compose. So go ahead and install Docker Compose, and I will see you in the next lesson. Before we get started, I want to show you a couple of techniques for cleaning up our workspace. So on this machine, we have a bunch of images and some running containers. They're getting in the way. I want to get rid of them all. How do we do this? Well, you know that we can remove images using Docker image remove command. And here we can type one or more image IDs. Now, how can we get all image IDs and pass them here? Let me show you a cool trick. So we can run Docker image ls. We see all the images, right? But if you pass -q at the end, we only get image IDs. Now we can pass this as an argument to Docker image remove. So Docker image remove. Now here we add a $, and in parentheses, we type that other command. So Docker image ls -q. Now if we run this, we're going to get an error because some of these images are already in running containers or stopped containers. So we should always remove containers first. We're going to do that using the same technique. So I'm going to replace image with container. So we get all container IDs, and then we're going to remove them all in one go. Also, I would like to add -a here as well. This will bring stopped containers as well. Okay. We can also combine switches. That's another technique. Let's go ahead. All right. We get an error saying you cannot remove a running container because I forgot to pass the force option. So let's bring this up one more time. When removing, we're going to use -f. Okay. Great. So all these containers are removed. Now let's remove the images. So Docker image ls and Docker image remove. Great. Now take a look. We don't have any images here and no containers, including stopped containers. So we have a clean workspace. That's one way. There is a shortcut for this as well. If you're on Mac, you can find the Docker icon on the top status bar. If you're on Windows, you will find it in your notification tray. Let's click on this and then go to Preferences. Now on this page, let's click on the troubleshoot icon. On this page, we have a bunch of useful utilities. For example, we can restart Docker Desktop. We can also clean and purge data. This will essentially remove everything in Docker, your images, your containers, your volumes, and so on. Now, be aware that if you click on this is going to restart Docker Engine. So on the top, look, you can see this animation showing that the Docker Engine is not started yet. So at this point, if you go to the terminal window and execute any of Docker commands, you're going to get an error. So you'll have to wait about half a minute for the Docker Engine to start. That's another way. So now that we have a clean workspace, next we're going to talk about our application. So in this section, we're going to look at a real-world application with multiple building blocks, a front end, a back end, and a database. So below this video, I've attached a zip file. Go ahead and download it. Inside that zip file, you're going to find this folder structure. We have this backend folder, which is our node project. This is a basic node project that starts a web server on port 3001. Once again, you don't need to know Node to go through this section. Then we have the front-end project, which is a React application that talks to the backend. Now, if you want to run this application outside of Docker, there are a number of steps we have to follow. Let's say we just check this out from a GitHub repository. First, we have to go to our backend project, install all dependencies, and then start the web server. Now, at the same time, we have to open up another terminal window and do the same steps with our front-end project. So we have to go to the front-end project, install all the dependencies, and then start the web server. And of course, we need 2 more terminal windows for running our front-end and back-end tests. And not to mention that, we should also download and install MongoDB on this machine. So there are so many steps we have to follow the moment we check out the source code from our GitHub repository. Now with Docker, we don't have to do any of these things. All we have to do is run a single command. Let me show you. So I'm going to get outside of the front-end folder. Now we are in the root of this project. If you look, here we have a file called Docker Compose, which is used for composing a multi-container application. We're going to talk about that in detail soon. Now, once we have this file in our project, we can simply run Docker Compose up. That's all we have to do. Now, Docker is automatically downloading this particular version of MongoDB. So it's downloading all these layers. Then at the same time, it's going to install all the dependencies for our front-end and back-end projects. It will start web servers and run automated tests all in this window. Now, this is going to take a little while, so I'll be right back. All right, our application is up and running, and we can access it at localhost port 3000. So here's what we get. We have a mini application for managing a list of movies. Now, you know what's the beauty here? The beauty is that our database is populated with these movies as part of bringing up our application. I didn't have to manually insert these movies in our database. So we have a migration script for populating our database, and Docker automatically executed our migration script as part of bringing up this application. This is a very common real-world scenario. Now here we can add new movies, movie 1, movie 2, whatever, and we can also delete these movies. So we brought up this application using a single command. Now, I briefly mentioned this file, dockercompose.yaml. Before we talk about this file, first you need to understand the YAML format. This is a format that a lot of people are not familiar with. So in the next lesson, we're going to talk about JSON and YAML formats. Let's talk about JSON and YAML formats. If you know these formats well, feel free to skip this lesson. So in the root of this project, we're going to add a new file called data.json. Now, JSON, as you probably know, is a language. It's a human-readable language for representing data. So in this JSON file, we can have an object or an array. Let's say we want to represent a course. A course can have properties like name, price, and so on. So in this object, we can add 1 or more key value pairs. Our keys should always be surrounded in double quotes. So we can add a key called name and set its value to, we can use a string, the ultimate Docker course. Then we add a comma to define the next key value pair. So we can say price. We can set this to a number. Now the value can also be a Boolean. So we can define another key value pair and set the value to true or false. We can define another key value pair and set the value to an array. So we define an array using square brackets. Now in this array, we can have any valid objects. So we can have strings, numbers, booleans, or other objects. So I'm going to add a couple of strings let's say software and DevOps. And one last key value pair, author. I'm going to make this an object. So once again, we use curly braces to define an object. In this object, we had a couple key value pairs. First name is Mosh, and last name is what? Hamadani. And yes, I am Iranian. I get that question all the time. All right, so here we have a JSON file. Now let's see how we can convert this to YAML. YAML is another language for representing data, but it has less clutter than JSON. It's easier to read. So I'm going to copy all this code. Here in the project, we're going to add a new file called data.yaml. The extension can be YAML or YML. Now, on the top, we add 3 hyphens to indicate the beginning of a YAML file. Then we paste our code. Now, in YAML, we don't use curly braces to indicate hierarchy. This idea has come from Python. If you have programmed in Python, you know that in Python, we use indentation to represent hierarchy. So we don't have curly braces. So let's get rid of these braces and remove the indentation. Good. Now, the next thing you need to know about YAML is that we don't have to use quotes. So we can bring up the replace dialog and replace all these double quotes with nothing. That immediately takes a lot of clutter away. Also, we're not going to use commas to separate key value pairs. So on the top, we have name, price, is published. Now, how do we represent a list or an array? We use hyphens. So I'm going to remove this. We press enter. Add a tab. On a new line, we type hyphen to define the first item in the list, software. Then at the same indentation, we add the next item, DevOps. Now, author is an object, but as I told you, we don't use curly braces, we use indentation. So because these two properties are indented, they belong to the author property, okay? So this is our YAML file. Let's compare this with JSON. As you can see, YAML is easier to read and understand. Now, why don't we use YAML all the time? Well, because parsing YAML files is a little bit slower than parsing JSON files, because the parser doesn't know if this is a string or a number. So it has to read everything as a string and then try to evaluate it. In contrast, in JSON, strings are represented using quotes and more specifically double quotes. So the parser knows that this is a string and it shouldn't evaluate it, okay? So quite often we use YAML files for configuration files and JSON for exchanging data between multiple computers, like a client and a server. So now that you understand these formats, next we're going to talk about compose files. All right, let's see how we can create a compose file from scratch. So for this lesson, I'm going to rename this file to underline Docker compose. We want to set it aside and create a new compose file from scratch. So here we add a new file called docker-compose, all in lowercase. Make sure to spell it properly. Otherwise, Docker compose is not going to find this file because this is the default name that Docker compose assumes. Okay. So YAML. Now, the first thing that we need to set here is the version property. What version should we use? Well, let's search for Docker compose file. On this page, you can see various compose file formats and their compatibility with Docker Engine. We are using the latest version of Docker Engine, so I want to use the latest compose file format so we have access to the latest features. So we're going to set this to 3.8. Now, here we need to wrap this number with double quotes. Otherwise, it will be evaluated as a number. But Docker compose expects this value to be a string. Why? I have no clue. So here's the version. Now, in this file, we define various building blocks or services of our application. So we have a property called services. Now, what services do we need here? Well, our application has a front end, a back end, and a database. Now, your application might have other moving parts, so you can define them here. Now, these names are arbitrary, so we can call them anything. We can change this to DB, we can change the backend to API, and the front end to web. The idea here is that we're defining various services and telling Docker how to build images for each service and how to run these images. So here we're going to have properties, and the value of these properties will eventually be used when running our containers. So in the previous section, we had to manually run our containers using Docker run. And here we used parameters like -p for port mapping or -v for volume mapping. We also had to specify an image like React app. All these values can be defined in our compose file. So we don't have to manually start our containers. Docker Compose will take care of starting our containers under the hood, okay? So for each service, we need to tell Docker how to build an image for that service. So here we can use the build property and tell Docker Compose where it can find a Docker file. So if you look at this project, you can see that in our backend and frontend folders, we have a Docker file. This Docker file is almost identical to the one we created in the previous section. So we start from a node image, we create a user, we set our working directory, copy all the files and install the dependencies, then expose port 3001 and start the web server. We have a similar Docker file in our frontend project. Let's have a quick look. So that was the backend, here's the frontend, and here we have a Docker file, almost identical. But the front-end application or the front-end server starts on a different port. That is the only difference. So each service should have its own Docker file, okay? Now, back to our compose file. For our web or front-end, we're gonna set the build property to period, meaning current folder, /frontend. This is where we have a Docker file. For our API, we're gonna set build to backend. Now for our database, we're not going to build an image. We're going to pull an image from Docker Hub. So instead of the build property, we're going to use the image property. Now for this application, I'm going to use Mongo version 4.0-Xenial. So that is Mongo version 4 built on top of Xenial, which is Ubuntu version 16. Now if you look at Docker Hub, you can see that Mongo also has images built on top of Windows, but Windows images are very large, over 2 gigabytes. So that's why I prefer to use Linux images. So for any of these services, we can either build an image or pull it down. Now here we also have port mappings. So we set ports to. Now because we can have multiple port mappings, here we need to use the array or list syntax. So we use a hyphen and then define a port mapping. So our front-end application starts on port 3000. So I want to map port 3000 of the host to port 3000 of the container running this image. Now, similarly for our API, we're going to define a port mapping. This one is going to be 3001 to 3001. Now, MongoDB by default listens on port 27017. So I want to map the same port so we can access MongoDB using a MongoDB client like MongoDB Compass. Now, if you don't use MongoDB, you have the same concept with other database engines. All these database engines listen on a default port. You want to map that port so you can connect to your database engine using your favorite database client. Okay? What else do we have here? Back to this page for compose file. If you look at version 3, on the right, you can see all valid properties. Now, a lot of these are for really special cases, so you don't need to use them all the time. But the ones that we use most of the time are build or image. We also use ports, volumes, environment, and so on. So our API project needs an environment variable that tells where our database is. So here we set environment. Now here we can use the list syntax because we can have multiple environment variables. So we set db_URL to, here we need to type a MongoDB connection string. These connection strings always start with MongoDB : 2 forward slashes. Here we need to type the name of a host. So as I will show you later in this section, when we start an application with Docker Compose, under the hood, a network is created. On this network, we're going to have 3 hosts. The name of these hosts are equal to the names we have defined here. So we're going to have a host called DB. So that is the connection string to our MongoDB server. Now, on this server, we can have multiple databases. So we're going to specify the database name and the connection string as well. So this is one way to set an environment variable. But instead of using the list syntax, we can also use the object or property value syntax. So we get rid of the hyphen. We say db_URL is a property, and this is the value of that property. I find the syntax more readable because we get color coding and it's just cleaner. Similarly, we can add additional environment variables. Now, we're almost there. The last thing we want to add here is a volume, because we don't want MongoDB to write data to the temporary file system of the container. So here we set volumes. And again, we can have one or more volume mappings. So we add a hyphen. We're going to map a volume called Vidly. And of course, we can call it anything. Vidly is the name of this application, in case you didn't notice. So we're going to map this volume to a directory inside the container. Now, if you look at the documentation of MongoDB on Docker Hub, or just a typical MongoDB documentation, you know that by default, MongoDB stores its data in /data/db. So we want to map this volume to this directory. So whatever that is written inside this directory is actually outside of this container. It's somewhere else in our volume. Now, because we have used this volume here, we have to define it in our compose file. So we press enter, remove all the indentations. So now we are at the same level as services. Here we're going to define another property called volumes. And here we're going to add another property called Vidly with no value. I know this looks a little bit weird, but this is the syntax we have to follow. We just have to define the volume first before we can use it. So this is our compose file. Now we can make this more readable by adding line breaks in between these properties. We can also order the services any way we want. So currently I'm ordering them from front to back. We can also order them from back to front. So we would put database first, then API, and then web. So we're done with our compose file. Next, I'm going to show you how to build the images. Earlier, I told you that Docker Compose is built on top of Docker Engine. So everything we have done with Docker Engine, like building images, listing them, starting containers, and so on, all of these operations are also available using Docker Compose. Let me show you. So we type Docker Compose without any arguments, enter. Look, we have all these subcommands, like we have rm for removing stopped containers, we have run, we have push, pull, and so on. The difference is that any of these commands will apply to our application as a whole. So most of these commands will impact multiple services or multiple containers in our application. So let's look at Docker Compose build and also use the help option. So we have a bunch of options here. A couple of them I want to point out that are useful to know is no cache. With this, we can prevent caching when building the image. Sometimes you encounter weird issues and you want to make sure that cache is not used. In that case, you use this option. Another useful option is --pull. With this, we can always pull a newer version of the image. That is also good to know. So in this lesson, I'm not going to use any of these. We're just going to run Docker Compose build. This built our web and API services. And as you noticed, our build was super fast because pretty much everything came from the cache. So let's run Docker images. So I have 5 images on this machine: Vidly frontend, Vidly web, Vidly API, Vidly backend, and Mongo. Mongo obviously came from Docker Hub. Now, as part of this build process in this lesson, we built Vidly web and Vidly API. These 2 other images, Vidly frontend and backend, were built when we started this application earlier. So back to our project. In this original compose file that I included in this project, look, I called these services frontend and backend instead of web and API. That is why we have these 2 images, Vidly frontend and Vidly backend. Also, as you have noticed, when building images with Docker Compose, our images are prefixed with the name of our application. Now, where does this come from? It is the name of the directory. So currently we are inside a directory called Vidly, and that is why all these images are prefixed with Vidly. I think this is a great convention. Now, I got a question for you. If you look at the created column, you can see all these images were created an hour ago. But didn't we just build the web and API images? Why do you think this happened? Here's the answer. Because I built these images, frontend and backend, an hour ago when I was recording the first lesson in this section. Now, when building these new images, Docker used everything in the cache because all those files were already available, all those layers were there. So Docker didn't have to do a full rebuild. That is why we are still using the build from an hour ago. Okay. Now, if you want to force a full rebuild, we can say docker compose build -- no cache. All right, this is going to take a few seconds, so I'll be right back. All right, our images are built. So let's run Docker images. There you go. Look at the first two images, API and web, were built less than a minute ago. So that's all about building images. Next, we're going to talk about starting the application. You briefly saw how we can start an application with Docker Compose. We just type Docker Compose up. Now, if the images are ready, Docker Compose will run them inside containers. Otherwise, it's going to build the images automatically. Now, before executing this, let's look at the available options. So here we have a ton of options. A couple of them that are useful are build. With this, we can force a rebuild every time we want to start our application. So we don't have to explicitly run Docker Compose build and then up. We can combine the two using the build option. The other useful option is -D for detached mode. So we will start these containers in the background. So take a look. All right, now if we run Docker Compose PS, we can see all the containers relevant to this application. In contrast, if we type Docker PS, we can see all the running containers across all applications, okay? So here we have 3 containers, Vidly, API1, Vidly DB1, and Web1. Now, what is this one? Well, we can start multiple containers from the same image, and this is used for high availability and scalability. It's something we'll look at in the future. So here you can see the container. You can see what command started that container. So for our API, that was npm start. For our database, that was MongoD or Mongo daemon process. And for our web frontend, that was npm start as well. You can see all these containers are up and running. And over here, you can see port mappings. So now if we go to localhost port 3000, we can see our application. Beautiful. Now, how do we take this down? Let's say we're done with this application and we want to free up resources. Back to the terminal, we type Docker Compose down. This will stop and remove these containers, but the images are still there. So next time we want to start the application, our application will start pretty quickly. Let's talk about networking in Docker. When we run our application with Docker Compose will automatically create a network and add our containers on that network. So these containers can talk to each other. Let's see this in action. So I'm going to bring up the application one more time in the detached mode. Good. Now look at the first line. Creating network with the default. So we can run Docker network ls. Here we can see all the networks on this machine. I think every Docker installation has 3 networks: bridge, host, and none. Honestly, I'm not sure what these networks are for, but what matters here is that we have a network called Vidly default. The driver for this network is bridge on Linux or NAT on Windows. Now, this network contains 3 hosts or 3 containers: web, API, and DB. So these hosts or these containers can talk to each other using their name. Let's see this in action. So back to the terminal, let's look at the running containers. So we have Mongo, web, and API. Now we're going to start a shell session on the web container and ping the API container. Take a look. So we're going to execute in the interactive mode. The container ID is 8CS6, and we're going to run shell. So let's ping API. We get a permission error because we have logged in with the app user. That comes from our Docker file, remember? So we have logged in with the app user, and this user doesn't have ping permission. So let's exit. I'm going to bring up the last command. Now here we have to use an extra option for setting the user. We're going to log in as the root user. Good. Now look at the shell prompt. We have a #, which means we have the highest privileges. So here we can ping API. Now look, we're getting responses from a machine with this IP address. Now on your machine, this IP might be different. Now let's press Ctrl+C to get out of this. So this is what happens under the hood. Docker comes with an embedded DNS server that contains the name and IP of these containers. Now, inside each container, we have a component called the DNS resolver. This DNS resolver talks to the DNS server to find the IP address of the target container. So when we ping the API container, this DNS resolver asks the server what is the IP address of the API machine or API container. The DNS server returns the IP address, and then the web container can directly talk to the API container using its IP address. So each container has an IP address and is part of a network. Let me show you one more thing. So back to the terminal. Here we can run ifconfig to see the IP address of this container. Take a look. So this container has two network adapters. One of them is Ethernet 0, and over here, you can see the IP address of this container. So 172.21.0.2 is the IP address of the web container. Now back to our compose file. Earlier when we defined the API service, we added an environment variable that contains a database connection string. In this connection string, we have DB, which is the name of a host. That is the DB host or the DB container. You saw that our API container can talk to this container because both these containers or all containers in this application are part of the same network. Now, one thing I want you to understand here is that this host is only available inside the Docker environment. So if I open up my browser and go to localhost/db, I'm not going to get anything. So the API container can directly talk to the DB container. But if you want to access this container, we need port mappings. And that is why we have this port mapping over here. So this port on the host is mapped to this port on the container. So if you open up MongoDB Compass, which is a popular MongoDB client, we can establish a connection to localhost port 27017 because this port is mapped to our container. Let's verify this real quick. So connect. Great. So here we can see all our databases. Here's our Feedly database. And in this database, we have a collection called movies with 4 documents. So here are the movies that we currently have in the database. So this is all about Docker networking. Next, we're going to talk about viewing logs. Let me show you a few different techniques for viewing the logs. So if we type docker compose logs, we can view the logs across all containers of this application in one place. Take a look. So here we have some messages coming from our database container. Above that, where is that? We have some messages coming from our web container. And these are color-coded. It's beautiful. Now, let's bring up this command and add --help at the end to view the available options. Here we have the same options we talked about earlier in the course. So using -f or follow, we can follow the log output so we can continuously see new messages as they come out. Also, we can add a timestamp using -t. Now, what if we don't want to see the logs for all these containers in one place? Some people have big monitors or multiple monitors. They prefer to have different windows for different container logs. That is very easy. So we look at the running containers. Let's say we only want to look at the logs for our web container. So we can say docker logs. Here's the container ID, HC6. And of course, we can follow this log as well. So here's the log for this container. You can put this on a separate window or on a separate monitor. So that's all about logs. Next, we're going to talk about publishing changes. All right, let's talk about publishing changes. So obviously, we don't want to rebuild our application images every time we change our code. So we're going to map our project directory, like the backend directory, to the app directory inside our container, exactly like before. This way, any changes we make in this directory are immediately visible inside our container. And of course, we have to do the same with the front-end directory separately. So let's open up our compose file. Here's the definition of our API service. In this definition, we're going to add a new property, volumes. Now we can have one or more volume mappings. So here we need the list or array syntax. Now here we can type a relative path. So starting from the current directory, we go to the backend directory and map this to the app directory inside the container. Now in contrast, Earlier, when we started our containers manually, we had to type an absolute path. So there, we had to use this syntax to get the current working directory and map it to the app directory. Remember? With compose files, we don't have to do this. So we can type a relative path here. That's a lot easier. So that's pretty much all we have to do to share our source code with our container. There's just one tiny problem. Let's go ahead and start our application. So Docker compose up, and I'm not going to use the detached option because we're going to encounter an error and I want you to see that immediately. So let's bring up the application. Great, we saw the error. Look, it says nodemon not found. What is this? Well, nodemon is one of the packages that our backend project is dependent on. So back to our project, here in the backend folder, we have this package.json, and if you pay close attention, you can see under dev dependencies or development dependencies, we have a dependency to nodemon or node monitor. Nodemon is a utility that watches all of our files, and anytime it detects a change, it restarts our node server. Now, this error is saying that nodemon cannot be found. Can you tell why? Here's the reason. In the backend folder, we don't have the node modules folder, right? Because we haven't installed npm dependencies on this machine. These dependencies were only installed inside the Docker container. But now that we're sharing our application's code with our container, what the container sees is essentially this directory. And here we don't have the node modules folder. So back to the terminal, let's stop this by pressing Ctrl and C. First, we go to the backend directory and run npm install. We can also type npm I. That's a shortcut. All right, all our dependencies are installed. So let's bring up the app one more time. All right, over here you can see nodemon is starting our node process. So let's go to our browser and head over to localhost port 3001/API. This is like the home page of our API. So our API is running. Now let's make a small change in our code and see if that change is visible here or not. So back to our project, here in the backend folder, let's go to route and then index.js. This is where we can change that message. So API is running. I'm going to add a few exclamation marks, save the changes. Now in the terminal, you can see nodemon detected our change and restarted our web server. So back to the browser, refresh, we can see the changes. Beautiful. Now we can apply the same technique to our front-end project. The steps are repetitive, so I leave it up to you as an exercise. Most of the time, when we release our application, we want our database to be in a particular shape with some data. This is called database migration. Now, in this backend project, I'm using a database migration tool called Migrate Mongo. So if you look at package.json over here, under dev dependencies, you can see we have a dependency to this package, Migrate Mongo. We have a similar tool in other development stacks. For example, in .NET, we have Entity Framework. In Django, we also have database migrations and so on. So you should probably be familiar with these migration tools. But if not, let me give you a 2-minute summary on how they work. So using these migration tools, we can create database migration scripts. In this project, our migration scripts are stored in this migrations folder. So currently we have one script. This is just a basic JavaScript file. In each file, we have two functions, up for upgrading the database and down for downgrading it. So in the up function, we're going to the movies collection and inserting these movie objects. And obviously, when downgrading the database, we're going to remove these movies. Okay, again, don't worry about the JavaScript code. Think about the concept. So we have one script, which is called populate movies. And as you can see, it's timestamped. Now, using a tool like Migrate Mongo, we can go to the terminal and say Migrate Mongo up. This will look at our migrations folder and execute all migration scripts. Now, what if we execute this command multiple times? Well, our scripts are not going to be executed twice. Because if you look at our database, look, here we have a collection called changelog. In this collection, we have the scripts that have been executed. So migrate Mongo will not execute the script multiple times, okay? Now back to package.json. In the script section, we have these commands, which are aliases for the command in front of them. So here we have db-up, which is mapped to migrate Mongo up. So here in the terminal, we can say migrate Mongo up, or we can say npm run db up. With npm run, we can run any of the commands in package.json, okay? Again, if you don't use Node or npm, you have a similar concept in your development stack, okay? So that's the idea of migration tools. Now, how can we execute the database migration as part of starting our application? Well, let's look at our Docker file in the backend project. So here's our Docker file. We talked about this before. We simply call npm start, and this will start our web server. Now, in our compose file, we can overwrite the command that we have here and do something else. So let's bring up our Docker compose file. Here's the definition of our API service. We can add a new property here, command. And here we can overwrite the default command in our Docker file. So here we can say migrate Mongo up and npm start. Now there's a problem here. It is possible that our database server is not ready at the time of executing this command. So even though our database container might be running, the actual database engine, in this case Mongo, may not be ready, because starting a database engine often takes several seconds. This is where we use a waiting script. So if you search for Docker wait for container on this page, which is part of Docker documentation, you can find a list of tools that give you that capability. So we have wait for it, Dockerize, shell compatible, wait for, as well as relay and containers. And of course, there is more. I've played with these tools, and the one that has worked for me personally is wait for it. If you look at this, this is just a GitHub repository and includes a shell script, waitforit.sh. With this script, we can wait for our database engine or any other processes to get ready before doing some work. So back to our Docker file, before migrating our database, we want to use our wait for script. Now, if you look at our project, you can see I've stored the wait for script here inside the backend folder. So here we can say wait for, then we specify the name of our computer or host, which is DB. That is the name of our container, right? Now we want to wait for port 27017 to receive traffic. That is the default MongoDB port, right? Once this is ready, then we're going to migrate Mongo. Now, as you can see, this command is a little bit too long, so there's another way to achieve the same result. We can create an entry point script. So once again, in this project, I've supplied a file called docker-entrypoint.shell. This is a basic shell script. So first we echo a message saying, waiting for MongoDB to start. And this is where we're using the wait for script. Now that Mongo is up and running, we print a message saying we're migrating the database, so npm run db up, and finally we start our web server. Now, we can go to our compose file and simplify this command. All we have to do is run our docker entry point script. Now, this is for Linux. If you're on Windows, you can write the PowerShell script to do the same thing, okay? So this is how we can migrate the database. Now, to verify this is working, let's go back to the terminal, stop this process. Now I'm going to bring down the application. So this has removed our containers like API, DB, and web, as well as our network. But our volume is not deleted. So Docker Compose doesn't automatically delete the volume in case we have some data we don't want to lose. So let's look at all our volumes. All right, here we have vidly, underline vidly. So the first vidly represents our application, and the second vidly is the name of our volume, okay? So let's go ahead and remove this volume, vidly, underline vidly. Good. So now our MongoDB database is gone. So now let's restart the application and see if we get a fresh MongoDB database populated with our movies. So Docker Compose up. Let's pray that everything is going to work. All right, I think we're almost ready. Okay, so back to the browser. We can go to localhost port 3001/API/movies. That's our endpoint. Beautiful. So all these movies are here. We can also access our front-end application at port 3000. Refresh. Beautiful. So our migration is working perfectly. Next, we're going to talk about running tests. All right, the last thing we're going to talk about in this section is running automated tests. So for both these projects, our front-end and back-end project, I've written a bunch of unit and integration tests. So we can go to our, let's say, front-end directory and run npm test. All right, we have 9 beautiful passing tests. So let's press Q to get out of this. Good. So this is one way to run these tests, and that's how I like to run my tests. Now, I've seen some people run their tests inside a Docker container. I've done this before and found it to be very slow. We want our tests to run quickly so we can get rapid feedback as we are writing code. But in case you're curious, let me show you how you can run your tests inside a container. So back to our compose file. Here's the definition of our web service. I'm going to duplicate this and then rename the second instance to web tests. Now, we're not going to build a new image. We want to reuse an existing image, the image that was built for this service. So we're going to change the build property to image. Now, what is the name of the image? Vidly_web. Now, do we need ports? No, we don't, because we don't want to access the service directly, like accessing our web service. Delete. What about volumes? We want to keep this here, so any changes we make to our application code or our tests are immediately visible inside this container, okay? Now, here we're going to overwrite the default command for this image and run npm test. So, save the changes. Now, let's get out of the front-end directory and run docker compose up. All right, our application is up, and over here, you can see the output of our web tests container. So all of our tests are passing, but if you go to our application code and make a change, it takes a little while until these tests are rerun. I find this to be a little bit slow for my taste, but if you like this approach, by all means go for it. The good thing about this approach is that you don't need to open up different windows and run tests for front-end and back-end separately. So just like we defined a service called web tests, we can define another service called API tests. So when we start our application, both the front-end and back-end tests get executed, and we see the result all in one window. But again, this is a little bit too slow. So that's all about running tests. We reached the end of this section. In the next section, we're going to talk about deployment. So I will see you in the next section. Welcome back to the last section of the Ultimate Docker course. In this section, you're going to learn how to deploy your Dockerized applications. So we're going to take the same application we have been working with and put it in the cloud. We'll be talking about various deployment options, getting a virtual private server or VPS, using Docker machine to provision hosts and connect with them, creating optimized production images, and of course, deploying the application and its updates. I think this is the most exciting part of this course because by the end of this section, our application will be live on the internet with its front end, back end, and database. So let's jump in and get started. To deploy our Dockerized applications, we have two options. We can deploy our application to a single host or a cluster, which means a group of servers. Now, as you might guess, deploying to a single host is really easy, but the problem with a single host deployment is that if our server goes offline, our application will not be accessible. And also, if our application grows rapidly and we get hundreds of thousands of users, a single server is not able to handle that load. That's why we use clusters. So with clusters, we get high availability and scalability. Now, to run clusters, we need special tools called orchestration tools. Docker has its own orchestration tool built into it called Docker Swarm, but as far as I know, it's not really that popular. I've done some research. Most people these days use another tool called Kubernetes, which is a Google product. Now, initially, I was planning to include Docker Swarm in this course, but after I did a survey and realized that only 5% of my audience really use Docker Swarm and everyone else uses Kubernetes, I thought that would be a waste of time and that would delay the production of this course. So I decided to drop Docker Swarm. Now, why didn't I include Kubernetes in this course? Because Kubernetes is fairly complex and really requires its own course or book. And quite frankly, it's not something that I know a lot about. So in this section, our focus will be on a single host deployment, which works for a lot of people. Don't assume that you need a cluster right from the get-go. You can always start simple, and if needed, you can transition to a cluster. So to deploy our application, we need a virtual private server or a VPS. Now, there are a ton of options to get a VPS. We have DigitalOcean, Google Cloud Platform, Microsoft Azure, Amazon Web Services, and of course, many, many more. These are the platforms that I personally have played with. Now, out of these, DigitalOcean is the simplest and most beginner-friendly one. And as we go down this list, we get more features, but at the cost of complexity. So I decided to choose DigitalOcean because I didn't want us to get distracted from Docker and go somewhere else. Now, all these platforms require you to provide a credit or a debit card to get a VPS. So to execute all the steps I'm going to show you in this section, you will need a debit or a credit card unless you already have access to a VPS. But if you don't let that discourage you. I still want you to watch this section so you have an understanding of the deployment process. So if you want to follow along with me, head over to digitalocean.com, create a new account, and then watch the next lesson. Once we have a server, we need to use a tool called Docker Machine to talk to the Docker engine on that server. So this way we can execute Docker commands in our terminal and our commands will be sent to the Docker engine on our server. So head over to github.com/docker/machine/releases. On this page, you can find the latest release. At the time of recording this lesson, it's version 0.16.2. Now down below, you can find the installation instructions for various platforms. It's super easy. We just have to copy this command and execute it in the terminal. So copy, paste it here, done. All right, Docker Machine is installed. Let's verify it. So Docker Machine --version. Perfect. So go ahead and install Docker Machine. When you're done, come back, watch the next lesson. All right, now we're going to use Docker Machine to create a virtual private server on DigitalOcean. So we type Docker Machine create. Now, this is going to be a long command, so we're going to split it onto multiple lines. Now, if you're on Linux, you can do this by typing a backslash at the end. If you're on Windows, you need to type a backtick, okay? And of course, this only works in PowerShell, not command prompt, okay? So backslash. Now on the second line, we type --driver. Now, Docker Machine has drivers for different platforms. If you Google Docker Machine drivers, you'll find this page. So we have drivers for AWS, Microsoft Azure, DigitalOcean, and so on. Now, if you have a server in your own network and not in one of these platforms, we can set the driver to none. But here we're going to use DigitalOcean. Now, another backslash or backtick to go to the next line. Now, here we need to supply an option specific to DigitalOcean. So if you use AWS or another platform, your options are going to be different. So that option is DigitalOcean-access-token. So now we need to go to DigitalOcean and get an access token so Docker Machine can talk remotely with DigitalOcean. So here on digitalocean.com, on the left panel, we expand account and go to API. And of course, this user interface might change in the future. So if you cannot find it, just search for API on DigitalOcean, okay? Now, here we can generate a personal access token. Let's go ahead. We're going to give this a name, Vidly, the name of our application, generate token, and here's the token. Now, this token is visible only once. So once we move away from this page and come back, we're not going to be able to see it. So copy this and keep it somewhere safe if you want to reuse it in the future, okay? Now, back to the terminal window, we're going to pass that token here and then add a space and a backslash at the end so we can type the rest of the command. Now, at the time of recording this lesson, there is a problem on DigitalOcean. We cannot install the latest Docker engine on the server. We have to use an earlier version. Now, put a link down below. If you open that link, you're going to see this page. This question was asked in December 21st, 2020. So it's fairly new. Now, down below, you can see the solution. So you have to add this extra option when creating a Docker machine. So with this, we can specify the engine install URL. So at this address, look, we're installing version 19 point whatever. Hopefully this issue will be fixed in the future and you don't have to add this option. So let's copy this line as well, including the backslash. And of course, if you're on Windows, you're going to replace that with a backtick. Now on the last line, we're going to give the server a name. We can call it Vidly or whatever. Now, Docker machine is going to create a virtual machine by that name. And on that machine, it's going to install Docker. So then we'll be able to talk to that Docker engine remotely on our machine. Now, this is going to take a little while, so I'll be right back. All right, our server is ready. Now look at the output. Docker machine was provisioning this with Ubuntu. This is the default image. Now, if you don't want to use Ubuntu, you can use a different image. So back to this page where we can see the list of drivers. Let's look at the DigitalOcean driver. Now down below, you can see all the available options. So we have an option for specifying the image to use, okay? Now, once Ubuntu was installed, then Docker machine tried to install Docker. So now we have Docker up and running on this machine and we can talk to it remotely. Also, if you go to the homepage of your account on DigitalOcean, you can see a new droplet called Vidly. A droplet on DigitalOcean means a server. Now over here, you can see the public IP address of the server. So we can copy this, open it in the browser. Currently, there is nothing there because we haven't deployed our application yet. So now that we have a server up and running, next I'm going to show you how to connect with this server. Let's see how we can connect to our server. First, we run docker machine ls. With this, we can see all of our Docker machines. So currently we have a single machine called Vidly that is not active. We'll talk about that shortly. Here we can see the driver for this machine, which is DigitalOcean. Our machine is up and running. Here we can see the IP address of this machine. In the next column, which is called Swarm, let me resize the window so you can see. All right, so here's the Swarm column. This tells us if this machine is part of a swarm or not. A swarm, as I told you at the beginning of this section, represents a cluster. So this is a single host. It's not part of a cluster. In the next column, you can see the version of Docker engine running on this machine. And currently we have no errors. Great. Now, to connect to this machine, we're going to use SSH. SSH is short for Secure Shell, and it's a protocol for connecting with servers. So using SSH or Secure Shell, we can open a Secure Shell session with our server. Now, if you have worked with SSH before, you probably know that setting it up is a bit of pain. There are a number of steps you have to follow so you can connect to a server using SSH. Now, the beauty of Docker machine is that it abstracts away all this complexity from us. So here we can simply type Docker machine SSH and then type the name of our machine, which is Vidly. Now, wait a sec. Okay, great. Now we're logged into our machine using SSH, and all of this was set up when we created this Docker machine. So as you can see, I'm logged in as the root user. We can look around. There's currently nothing in my home directory. Let's get out and run ls again. So here we can see the file system for Ubuntu. Our application is not deployed yet. That's why we don't have the app directory. So looks like our server is in a good shape. Next, we're going to talk about defining the production configuration. All right, this compose file we have created is great for development, but it's not ideal for production. For example, in our production environment, we don't need this volume mapping because we added this only for sharing our source code with our container. Similarly, we don't need this other container because we don't want to continuously run our tests in the production environment because this is going to slow down our server. It's going to unnecessarily use resources. So we're going to create a separate compose file for our production environment. So I'm going to copy this file, paste it, and then rename it to docker compose.prod.yaml. This is an arbitrary name. You can call it anything, but this is a convention that a lot of people follow. Now, let's modify this file bit by bit. So for our web service, we're going to keep the build property, but I want to use a different port mapping. I don't want to use port 3000 on the host because I want to type the host name in the browser and bang, I want to see the application. So we want to map port 80 of the host to port 3000 of the container. Now, we don't need the volume mapping. Good. Next, we're going to get rid of the web tests service. Now for our API, we're going to keep the build property. I'm going to keep the port mapping as well. Next, we have our environment variable. This is totally fine, but we don't need this volume either. Good. Now, our database service is in a good shape. We don't need to make any changes here, but I want to add an extra property to each of these services, and that is our restart policy. So we set restart. The default value is no. So that means if this container crashes, it's not going to be restarted. Our application will be unavailable. So then we have to connect with our server using SSH and manually restart the container. We don't want to use this. We want to use one of the other possible values. Earlier, we talked about the compose file format. So if you Google compose file format, you can find this page. Now over here, we can see version 3 of compose files. Here we can see all the valid properties and their values. We're going to look at restart. So where is it? It's right here. So here are all the possible values. We have no, always, on failure, and unless stopped. Always will always restart the container. On failure will only restart it if the container crashes. And unless stopped is kind of similar to always. The difference is that it will only restart the container if we manually stop it. So I'm going to change this to unless stopped. Now I want to use the same restart policy for the other services. Good. So now we have a compose file for our production environment. Similarly, we could create a compose file for our test and staging environments. So here are the images I have on this machine. Now look at our web image. Look at the size of this image. It's 300 megabytes. In this lesson, I'm going to show you a cool technique to reduce this image size beyond your imagination. First, I have to give you a bit of background about React. So back to our project. Let's go to the front-end folder and open up package.json. So here in the script section, we have a bunch of commands. You have seen start and test so far, but we also have the build command for creating optimized assets for production. So we can go to our front-end directory and run npm run build. This is going to create optimized assets for production. Now, as you can see here, all these assets are stored in the build folder. Now, what if you don't use React? Well, these days, a lot of frameworks have the same concept. They have a tool for creating optimized assets for production. How you use that tool is probably different, but that is irrelevant. So back to our project, here in the front-end folder, now we have this build folder that contains all the assets we need for deploying this application. So we can put these assets inside the web server and serve them. Now, let's see how we can create an optimized image for this front-end application. So let's look at our Docker file. What are we doing here? We are starting from a node image so we get access to NPM for installing these dependencies. But what if we already have these dependencies? Then we don't need NPM. We don't need node. All we have to do is copy these files onto a web server. Okay? So this is where we need to create a separate Docker file for production, because the changes we're going to make only make sense in our production environment, not for development. So back to our project, I'm going to copy this file, paste it, and then rename it to dockerfile.prod. And of course, we could call this anything. This is just a convention. Now, in this file, first, I want to get rid of all these white spaces because I want to restructure this code in a slightly different way. So on the top, we're starting from node. We're going to add an additional keyword here as to give this stage a label. We can call this anything like build stage. So in a Docker file, we can have multiple stages. We can have a build stage and a production stage. We can also add a comment here to make our code more readable, saying step 1, build stage. Now, while building this application, we don't need this user. This is only used for serving it, right? So I'm going to cut these 2 lines from here and move them down below. We'll get back to them in a second. So we create our application directory, copy all the files, install the dependencies, copy the other files. Now we don't need to expose a port here. Again, this is used for running the application. So I'm going to cut this line and move it here. Now, instead of npm start, we're going to run npm build, because in the build stage, we just want to build our application. Also, we're going to replace the command instruction with the run instruction, because as I told you before, we can have a single command instruction in a Docker file. And this is used for specifying a default command when our container starts. So let's get rid of this. We're going to use run, npm run, build. So at the end of this stage, our application is built. Now we're going to start the second stage. How? Well, we're going to add another from statement, but this time we're not going to start from Node, because for our production, or for running our application more accurately, we don't need Node. We just need a web server. There are many web servers out there. We have Nginx, Apache, IIS for Microsoft, and so on. In this lesson, I'm going to use Nginx because it's a very popular and fast web server. Now, Nginx has different tags. I'm going to use 1.12-Alpine. So this is Nginx 1.12 based on Alpine Linux. Super small. Now, if we want, we can give the statement a label as well. So we can call this production stage. We only need this if we're going to refer to this later in this file. We're not going to do that, so I'm going to delete it. So in the second step, which we can specify here using a comment, we can say step 2. This is for production. We're going to start from a web server image, which is far smaller. Then we create our user. Now we're going to copy our files from the build stage. So here we add an option called from. And this is where we reference our build stage. That is why we gave it a label up here. Okay. So we're going to go to our build stage and copy all the files from /app/build to /usr/share/nginx/html. Now, this path you see here is a standard path for serving files using Nginx. You can find this in Nginx documentation on Docker Hub. Now, instead of exposing port 3000, we can expose port 80, which is the default port for web traffic. Then finally, we can specify a default command or an entry point. In this case, I'm going to use an entry point because every time we start this image, I want this command to be executed. There are no exceptions. So we're going to run nginx and give it a couple of arguments. The first one is -g. The second one is daemon off with a semicolon at the end. Now, once again, you can find these arguments in the documentation of Nginx. There is nothing magical here. So now that we have a Docker file for production, let's build an image using this Docker file. So here in our front-end directory, we're going to run docker build -t. I'm going to call this image vitli_web_opt, meaning optimized. Now we need to specify our Docker file. So -f dockerfile.prod. And then we use a period to specify the build context. All right, our build is ready. So let's look at our images. Take a look. Here's our new image. Look at the size of this image. It's only 16 megabytes. It's a huge improvement. So when deploying this application, instead of transferring a 300 megabyte image, we transfer a 16 megabyte image. Now there's one more step left. So in our front-end directory, we have two Docker files, one for development, the other for production. Now, here we have two compose files as well. We have to go to our production compose file and tell this compose file that we want to use the production Docker file in the front-end directory. So we're going to expand this build property and give it two sub-properties. One of them is context, which we set to the front-end directory. The other is Docker file. So what we had earlier was the shorthand syntax. This is the longhand syntax. Here we're going to type our Docker file name, dockerfile.prod, and we're almost done. Now we should also change the port mapping because now in our production Docker file, we're exposing port 80, not port 3000, right? Okay, good. Now let's verify it's working before moving on to the next step. So back to the terminal, let's get out of the front-end directory. We're going to run docker compose build, but first we have to specify our compose file, docker-compose.prod.yml, like this. Let's go. Good. The build was super fast because everything was in the cache. So let's look at our images one more time. So here's our new web image. Look at its size, 16 megabytes. Beautiful. So now with this amazing optimization, we are ready for deploying our application. And that's what we're going to do next. All right, now the fun part. We're going to deploy this application. First, we're going to bring up the list of our Docker machines. So we have this Vidly machine on DigitalOcean. Now this Docker machine has another command called env for seeing the environment variables that we need to set to talk to this Vidly machine. So take a look. Here are a bunch of environment variables. Now we're not going to manually set these one by one. Instead, we're going to execute this last command. So let's see what's going on here. We're using the eval command on Linux and giving it this argument. You have seen this syntax before, right? So if you have a $sign and a pair of parentheses, whatever is inside the parentheses will be evaluated first and then passed as an argument to this eval command. So inside the parentheses, we're getting all the environment variables to talk to this machine. Now we pass all of those to eval and eval will execute them. So let's copy this line and paste it. Good. Now in the past, we had another command called activate. So we could activate the machine. I don't know why they removed this. This was much easier to work with. But anyway, so now that these environment variables are set, any commands that we type here will be sent to the Docker engine on this Vidly machine. So our Docker client, this Docker client here, will be talking to the Docker engine on this machine. Take a look. So Docker images, look, it's getting a little bit slower because the command is going over the network. So on this machine, we don't have any images. Now, here in the project directory, to deploy our application, all we have to do is run docker compose up. As simple as that. So docker compose up. Now we want to supply our production compose file. So docker compose.prod.yml. And I'm also going to use the detach mode. I made a mistake. I should have put -d at the end. So let's bring up the last command. So up -d. All right, good. So now it's creating this network, this volume. It's trying to build an image for our backend, I believe. Now here we might get a permission error. Let's see if it happens or not. All right, we got a permission error saying missing write access to the app directory. To understand why we're getting this error, let's go back to one of our Docker files. So this is the Docker file for our backend project. Now look at this instruction, work there. In the older versions of Docker, this instruction didn't respect the user instruction. So even though we set the user here, work there created this directory using the root user. And the root user is the only user who can write to this directory. Now this issue is fixed in the latest version of Docker because the latest version of Docker uses a different build tool called the build kit. If you have noticed, when we build images locally, our build output is different from what you see here. This is the old build tool. The new build tool, which is called the build kit, gives us colorized output. So some of the lines are blue. You have noticed that, right? So the reason we're experiencing this problem here is because on this VPS, we're using an older Docker engine. And this is a temporary problem with DigitalOcean. Hopefully you will not encounter this in the future. So you can install the latest version of Docker engine and everything will work magically. So what should we do here? Well, we have to go back to our Docker file and instead of relying on the work there instruction to create this directory for us, we have to create this directory using the root user and change its owner to the app user. So before we set the user, we have to run mkdir/app and using this command, we can change the owner of this directory. So we're going to set the owner user to app and the owner group to app as well. And here's the directory. Okay. So we create this directory and change its owner to app. Then we set the current user to the app user and everything else is fine. So with this change, let's bring up our application one more time and see if we encounter any other issues. So back to the terminal, we're going to run Docker Compose. Then we're going to give it our production YAML file. We're going to bring our application up in detached mode, and we want to use the build option so our images are rebuilt. Okay, our application is up. So let's see if we can access it in our browser. First, we need to find the IP of our server. We can go to DigitalOcean's control panel, or we can run Docker machine ls. So here's the IP address of our web server. So let's copy this. Now, back to our browser, let's go to this address. Nothing is here. What is going on? That's a great opportunity for troubleshooting. So our front-end application is not up, but what about our backend application? Our backend application is available on port 3001/API. Okay, so our API is running. We can also go to API/movies. So all movies are fetched from our database. That part of the application is working perfectly fine. The only problem is in the front end. So back to the terminal. Let's look at our running containers. Okay, so here's the web container running Nginx. Now, if you look at the status column, you can see that this container is restarting. Let me resize my window to show you this message. So, okay. It looks really ugly, but I will do my best. So here is the web container, okay? And you can see that this container is constantly restarting. That's because of the restart policy that we applied. So something is wrong in this container. It keeps crashing and restarting. So what is the next thing we need to do? We need to look at the logs. So let me resize this one more time. Good. So let's bring up the container list again. All right. We need the ID of this container to look at its logs. So Docker logs, and here's the container. Good. So take a look. There's so much going on here. All these repetitive messages are saying the same thing. We have a permission problem. And here we're getting a warning saying the user directive makes sense only if the master process runs with the super user privileges. The reason we're encountering this issue is because we're running Nginx with a non-root user. So back to our production Docker file in our front-end project. Look, this is where we're creating a custom non-root user. Now, we can definitely run Nginx with a non-root user, but setting it up involves a bit of configuration and some Linux work. It really goes outside the scope of this course. If you're interested, you can read the documentation of Nginx on Docker Hub. So to go forward, I'm going to remove these two lines and run Nginx using the root user. Of course, as I told you before, this is not the right way to do this, but I don't want us to get distracted from what we are doing. So now we have to go back to the terminal and redeploy our application. So Docker Compose -f, Docker Compose.prod.yaml. We're going to bring the application up and use the build switch to rebuild each image. Okay, it's going to take a while, so I'll be right back. All right, our application is up. Let's verify that all containers are running. Great. So now if you look at the status column, you can see that the web container is running. Great. So back to the browser. All right, we can see the homepage of our application, but we cannot fetch the movies. So we need to troubleshoot one more time. Look, I deliberately included these issues in this lesson so you learn troubleshooting skills. I could have executed these steps in a way that you could never see these, and everything looked so clean and polished. So how do we troubleshoot this? We're going to bring up Chrome DevTools and look at the requests sent to our API. So here's Chrome DevTools. In the Network tab, we select SHR to look at our API requests. Then we refresh by pressing Command and R on Mac or Control and R on Windows. Okay, here's the bad boy. Take a look. Look at the URL of this request. It's going to localhost port 3001. This is only for development. Our front-end application running on the web shouldn't send a request to localhost. It doesn't make sense. So back to our project, let's go to the front-end folder, source, services, and API.js. This is where we have all the code for talking to our API. So look at this line of code. We are saying, if this environment variable is set, use it. Otherwise, use localhost port 3001/API as the default value. So what we need to do now is to set this environment variable in our production Docker file. So we're going to go to dockerfile.prod for frontend. Now, in the build step, this is where we need to set the environment variable, because in React, environment variables are processed during the build stage. So the build tool that comes with React reads all these environment variables and hard codes them in the final code. Okay. So before running the build, we can say environment. Here's the key. We're going to set this to the IP address of our server. So let's run Docker machine ls. All right. Here's the IP of our web server. We're going to grab that. First, we'll start with HTTP. We add the IP. Now the port is 3001. And here we should also add /API. So save the changes. Now we need to redeploy. So here's our last compose command. Again, we're using the build option, so our images are rebuilt. Let's go with that. All right, perfecto. So let's go back to the browser, refresh, and here are all the movies. Great. So our application is up and running on our internet. So let's quickly recap. If we put aside all the little issues that we encountered in this lesson, deploying Docker applications is actually very easy. First, we have to activate a Docker machine. So we run Docker machine ls. Let's say we want to deploy to this machine. This could be our production machine. We could have another Docker machine for our test environment. We could have another one for our staging environment and so on. Once we know where we want to deploy this application to, we run Docker machine env with the machine name. So we get the command that we need for activating that machine. We execute this command. Good. Now this machine is active. So any commands that we execute using this Docker client will be sent to the Docker engine on the target machine. So here we can bring up our application using Docker Compose up. As simple as that. And if you think this is too tedious and you have to execute multiple commands, you can simply put these commands in a shell script like deploy.sh. And every time you want to deploy, you just run that script. So in that script, you're going to activate your production machine and then run Docker Compose up with the right options. Earlier in the course, I told you that you should properly tag your images before deploying them to various environments. So in this window, we're still talking to our production machine. Let's run Docker PS. Okay, look, on this machine, we have this image called Vidly_web, but we don't know what version of our application is included in this image. This is the problem I was talking about. So if we encounter inconsistencies amongst different environments, let's say our application works in a certain way in the staging environment, but not the same way in production. We don't know what version each environment is running. So we want to properly tag our images. How? Back to our production compose file, look at the definition of the web service. Here we have the build instructions, but in addition to build, we can also add the image property to tag this image. So we can say this image is going to be called Vidly_web, let's say this is version 1. Now similarly, we can add the image property to our API service and say, once this is built, it should be called Vidly API version 1. Save the changes. Now we're going to redeploy. So let's run Docker Compose again using the build option because we want to rebuild our images, right? Let's go ahead with that. All right, our application is redeployed. So let's run Docker PS one more time. Great. Now we can clearly see in production, we're running Vidly version 1. Now tomorrow, if we decide to deploy a new version, we have to go back to our compose file and manually update this and then redeploy. This is not ideal. That's why we use continuous integration and deployment tools. Using continuous integration and deployment tools, we can automate our deployment process. So we can configure our tool to check out the latest version of our code from our GitHub repository. Then it will build our image and tag it according to the latest build number. Or we can have our tool tag our images based on the latest commit. This way we can easily trace what version we are running in each environment. So instead of an arbitrary number here, we will have our git commit ID or the build number. That really goes outside the scope of this course and is something you need to learn on your own. So that brings us to the end of this course. I hope you have learned a lot and I'm going to see you in my other courses. If you enjoyed this course, please support me by telling others about it. I really appreciate your support. Once again, thank you and I wish you the best.